Check the mic, 1, 2, this ain't no game. Got the real G's in the house, speaking the name. Rocky France, AJ Rodriguez, Don Baar on the scene. Ben Bass, Emil Gera, Bobby Denney, know what I mean? Zac West, Wiese, Steve Lloyd, the whole damn crew. Dropping knowledge on y'all, keeping it true. May 3rd Sunday, mark the date on your calendar. Eastern time, 5 Pacific 2, ain't no wonder. We talking about the struggle, the hustle, the street. Over 300K folks in Cesyk can't be beat, but 75% are getting played, caught in the lie. IL's trash, a cancer, making good people cry. This the real talk, the uncut, the raw truth. Cesyk live, bringing justice for the youth. We ain't backing down, we standing tall and strong. Calling out the fakes where they all belong. This ain't for the weak, this for the ones who know. The elephant in the room, we about to let it blow. See, the industry's poison, the integrity's gone. The charlatans peddling garbage from dusk till dawn. They prey on the hopeful, the dreamers, the naive, feeding them lies, making it hard to believe. But the true professional, we here to expose the damage they causing from heads to their toes. This the real talk, the uncut, the raw truth. Cesyk live, bringing justice for the youth. We ain't backing down, we standing tall and strong. Calling out the fakes where they all belong. This ain't for the weak, this for the ones who know. The elephant in the room, we about to let it blow. We gotta unite, gotta rise above the hate. Speak truth to power, seal their fraudulent faith for the culture, for the future, for the respect. Relaying it down, showing them what to expect. Yeah, Cesyk live, roundtable coming real soon. We breaking it down under the sun and the moon. No more deception, no more backdoor deals. Just the real deal, that's how the story reveals. See it. Yeah. Y'all better be ready to listen. We shutting it down.
What's up, guys? Welcome to CESYK Live. Tonight, the elephant in the room. We're talking 1L. Guys, we're going to talk about what is it? Why is it on our mix? Where did it come from? We're getting all the nitty gritty here. We got some great guys on the panel here, and we're going to break this down. We're going to try to find out some answers along the way. I'm not going to tell you that we're going to get all the answers, but panels like this are what it's going to take to get all the answers. And we're going to have some pretty good tips tonight. Guys, we got some great people. We got Mike Griffin here. Mike, how are you, buddy?
I'm always good, brother.
All right, Mike Griffin. We got our house expert, Mr. Don Baar. How are you, Don?
I am fine, and I'm still vertical.
That's a good thing, right? I mean, unless you're tired, in which case you need a nap.
Yeah.
All right, and just to the side of him there on my screen, Mr. Ben Wiese. How are you, Ben? Or Wise? How do you say it?
Wiese.
Wiese.
It's Wiese.
So.
Yes, sir. Thank you. Ben Wiese, president of Green Umbrella, and happy to be here today. Been 21 plus years at Whiteman, now 6 plus at Green Umbrella, and here, to help with the finishing, with the curing. Longtime ACI curing member, and chair of 310 Decoratives. So here to supply and help all of our finishers out there.
Awesome. Well, we're really glad to have you, man, and we're real grateful for you tuning in tonight. We'll go down here. Let's see, this way. Mr. Steve Lloyd on my screen. How are you tonight, Steve?
How you doing?
I'm
we're,
well.
we're doing good. We're doing good. I'm Steve Lloyd. I'm from Bedford, Virginia. Started concrete finishing in 1972 in the good old days.
Yeah.
I was thinking about retiring until 1L came along, and they gave me new life. So I got to fight.
All right, fair enough. Well, we're glad to have you here to fight that
Thank
fight and to help to pick some of these guys' brains. So thanks for tuning in. Just below me here, Sam. How are you, my friend?
Good. How are you guys tonight?
Doing well.
Sam Klucker. Yeah, excuse me. Materials engineer. I work for one of the bigger flatwork companies that works nationwide. We see it all coast to coast. I'm quality control materials engineer for them. We also have our own batch plant, so I design our mixes and I review every mix from everybody across the country that comes into us. So we know the good and the bad. The also on got countless ASTM committees. I can't even count them up anymore. Even fathom how many of those there are in the queue. And then ACI 130 for sustainability.
Nice. Well, there's some definite knowledge there that we can't wait to get into. So we're grateful to have you here tonight, man. Thanks for tuning in. All right, just to his side, Mr. Zac West. How are you, Zac? You've been in the panel before.
Yep.
I think in one of our other hot seats. So returning member. So it's nice to have you.
Absolutely. Thank you. I kind of got my experience with 1L the way that a lot of people in our group have, and had a couple of slabs go pretty bad and fell down the rabbit hole and haven't poked my head back out yet. ACI certified advanced flatwork finisher, just got added to ACI 110 for tolerances. So just going to try to give what we know and help people out.
Awesome. That's what it's all about here. We're glad to have you, man. Just to the side of him there, Emil Gera. How are you, Emil?
I am good, Rocky. How about yourself, my
I'm
friend?
doing well, man. It's good to see you.
So, Emil Gera from Weatherly, Pennsylvania, second-generation concrete finisher. My dad had me in the mud at 8 years old, still at it at 50. So we focused mainly on decorative in the past 20 years, and we see the 1L hitting that sector pretty hard. So here to try to help find solutions and hear what other guys are going through as well.
Awesome. I'm sure a lot of guys will be proud to have you here as their voice, so we're glad you tuned in, man. And then down straight below me, all the way down to the bottom on my screen here, Mr. Ben Bass. Ben is a former CESYK member also. He was one of our very first ever, actually. So make sure you go to the vault, check that out on YouTube. Ben, how are you, brother?
I'm doing good, Rocky. It's a pleasure to be here, man. Yeah, similar to Emil, second generation concrete finisher, contractor. You know, obviously we've heard about type 1L. That was a hot topic spreading throughout the industry all over social media 6-7 years ago. You know, obviously it sucks when you hear about all this stuff that people are going through, but I got to say, Rocky, when it hit our area and it hit us and it started hitting us financially and our reputation, it's just a different type of feeling. And you feel bad for people going through it, but when it's you personally, man, it just pulls at different heartstrings. So I'm here as a concrete finisher representing the people that work with this stuff with their hands, and I'm just trying to get an understanding and hope that it spreads to other people that they can find some help as well.
Absolutely. And that emotion right there is what so many of the guys in the industry are feeling. So I'm sure that you're gonna get their point across too. So we're glad to have you tonight, buddy. And then just to the side of him there, Mr. Bobby Denney, also a CESYK vet. Also check his interview out on the vault there on YouTube. Bobby Denney, how are you, buddy?
I'm doing wonderful, Rocky. It's good to see all you gentlemen tonight, man. Bobby Denney from Delaware, Newcastle, Delaware. I'm a ACI advanced flatwork finisher. Some of the guys that taught us are on the panel here, Steve Lloyd and Ben Wiese. I'm the owner of Dencon Concrete Services, and we do both. We do residential work and commercial flat work. And I'm here as a finisher and basically as a liaison from the customer to the cement company. You know, that's why I'm here tonight, man.
Awesome. Well, we're glad to have you here and glad you tuned in, man. So, guys, we got right. I say we just get right into this. I know we have a whole list of questions each one of us want to get to, and probably most of them are kind of going to be along the same lines. So I say we kind of start with the very first one. But before we get into it, those of you tuning in live right now, if you have questions along the way, shoot them in the comment section. Mike is going to be following along, and he's going to interject now and then when we get a good question. He'll pop it in. So, and he's not going to try and sugarcoat it and admit and mod it up and whatever. He'll put it out just like you want him to say it, obviously within context.
we don't need a paragraph, because then by the time you read the paragraph, you don't even realize it's a damn question. So if you've got a question, try to be specific.
Valid point. All right.
A little bit short.
Let's get right into it. So let's start right at the top. What is 1L? Who wants to tackle that question? Let's one of these smart guys here. Let's do it. And then if we need to break it down for finisher language, we can do that. So, Ben, you want to tackle that?
Actually, I'll throw that one to Sam.
Let's go for it.
Sam actually, just because I like his answer.
Okay.
I already know what this is.
Good.
Oh man, see, now you're prepping that up for the bad answer instead of the correct one. All right, so 1L is as Portland cement limestone, where the old ASTM C150 allowed up to 5% limestone addition, and this new 1L PLC, whatever you guys want to call it, falls into a C595 that allows up to a 15% limestone addition. So the limestone that's being added is limestone on top of the limestone that's being used to manufacture the cement itself. They start out in the preheater together, and then most of the cement goes this way down the line to make the clinker, and some of that dried stuff goes off this direction, turns down, and gets reintroduced without being calcined back into the cement. The short technical answer there. So It is regular old cement. The clinker is the exact same, but there's more limestone in it than there was previously allowed.
So we've always had limestone in our mix, just lower tolerances.
Correct. Since 2004, I believe, C150 allowed. Before that,
02.
It was
02.
There was some in there, but then it was officially allowed to go up to 5% in 02, 04. I introduced in 04 or 02, I think made official in 2004, possibly. I don't know. I don't know where I was at way back then. That was a long time ago. But it's been in your normal cement already, just in a lower edition.
Okay. That's pretty finishered up for us. I think I can understand that. Okay, so I guess
So one clarification on that one.
Yes, absolutely.
While we are adding limestone to it, we are taking Portland back out of it. Okay, so it's a swap.
Okay.
Right?
Okay.
Hey, yeah. By percentage wise, yeah, Portland's all still in there. There's just more. There's more limestone added. They didn't actually. It's cutting. I mean, say it's like you got some vodka and you want to cut it down from 90 to 80% or something. It's you're diluting it you're diluting the original clinker with a little bit more limestone.
Okay.
Right.
Okay. So it does take a little bit. I mean, by volume, it does take a little bit of the good stuff out and make up. Okay.
Yeah.
Okay.
Correct.
Okay. That makes good sense. I think that's pretty straightforward. Ben, Bobby, you guys, that makes all good sense. Emil, right?
Yeah.
I think we can go on from that. So why raise those tolerances? Why would we even think about doing that?
Waiting
Ben?
for the answer
Sam?
from the sustainability committee, or go ahead.
I mean, why do we even have it? Why are we even seeing this? Because the average finisher is going to say, "Well, why don't the stupid plant just not buy it?" Well, duh. Why not just not buy it? Why don't they get the Type 1? I'll pay more if they have the Type 1.
Yeah, it's about the GWP, Rocky.
Okay.
The global warming potential.
Okay.
And so as all of this came down, and it is a hot topic, because really it's being driven by certain of the larger entities that are absolutely required. Basically there's green that's tied to all of this.
Okay.
So when they're looking, even for their funding, okay, they're required to have a certain amount of sustainability, and that's where Sam was joking about the sustainability committee, right?
Sure.
Because there's a whole other side to this.
Okay.
And they're required to meet certain sustainability requirements for their funding, even by their shareholders. They're being held accountable. What are you doing for global warming? Well, one of the ways that they can accomplish those tasks are beating up those of us at the very bottom, taking care of that concrete. Okay. So here you get this cleaner concrete, right? However, we're here today to talk about some of those sensitivities that everyone's seeing.
And
with that,
cleaner in that, how would this be cleaner? Because we're using less fuel to power the kilns less, kind of a thing?
That's exactly it, in a way.
Yes, in a way. So the whole thing with this is cement's being picked on unjustly and unfairly because the
cement.
Right, and the cement concrete is the second most used material on the planet next to water itself, and 8%, 7 to 8%, I think, of global CO2 emissions are from the cement industry. It's not even so much the burning of the fuel to run the kiln. It's limestone contains CO2. To make the cement, you have to drive that CO2 off the limestone. It's called calcification. And when they heat up the limestone, it reduces the CO2. It eliminates the CO2. It shoots it up the stack and it's gone. And that's what's getting into the air and causing the emissions for the most part. I think it's like 80% of the CO2 emissions come from the limestone itself, and like only 20 from the actual burning of tires and oil, whatever they're firing the kiln with.
Sure.
So they're making cement it's because we make so much of it. That's the ticket. It's a very sustainable material to start with. It is like next to bamboo, there's nothing better. Sure. But it's the massive volume that we use of it that it makes it easy pickings, because when you look at this big chart with all these other CO2 emitters and all this other material across the planet, cement stands way out by itself because it's 8% alone. And so easy target to pick on.
Okay.
So that's what they basically did, was picked on it.
Yeah, Rocky, when we're looking at the CO2 basically that's created by producing cement and the cement powder, right? Just like Sam was talking about right there.
Yeah.
Right. It is actually, if it was a country, okay, so if cement production was a country, it'd be the second to third largest emitter of CO2 in the world. And so that is why that they look at it and go pound on it. Okay. Sure. It's an easy target, like Sam said, because true sustainability wise, there's nothing more sustainable than a concrete building that's properly constructed.
Sure.
Right. It's got better thermal efficiencies. Everything about it is better. It's going to live longer. It's more sustainable from a standpoint of, can we remodel it in 25 years? Okay. Try and do that with a stick frame apartment house. It's turned into a slumlord, right?
Yep.
But not concrete.
Sure.
So,
Bobby, did you have a question?
I did. I just want to, is this globally or just nationally?
Globally.
Okay.
Globally.
Global push.
Like,
so, go ahead, Ben.
Europe is actually running up to 30% limestone in their cement at this point.
Yes.
Really?
Yep.
Yes.
Do we have any guys from Europe in the group, Mike?
Oh shit. A ton.
Are they talking about it right now? Like, are they? I mean, 30%. They should be flipping out way more than us, or they got something figured out.
Different times.
They've been doing it since the 80s, though.
Yeah,
it's been implemented since the 80s, and they have a different. Their limestone is a lot different quality than what we have. An LL limestone is it's more of a hard rock, whereas ours is super porous. So their mix designs act way different than what we get out of our limestone.
That makes sense. Ben Bass, go ahead.
Yeah, before we get too far along, I wanted to go back to what Sam said. So from my understanding, I believe you just said that making a Portland cement contributes 7 to 8% of the overall carbon footprint, correct?
Right.
That's correct.
So when they take up to 15% of that out and replace that with this filler, how much is that reducing that emissions of the 7 to 8%?
Man, you have to. That is a massive question. That's a huge calculation of sorts. It's measured in kilograms per cubic meter of tons per. Cement's a weird one because it's done by tons per cubic meter instead of concrete, where we're doing it in kilograms per cubic meter. But I think it's kilograms per cubic metric ton of something of that. And there's that increase. It's a straight 10%. Like if you're going from 5 to 15, it's a straight 10% decrease in the overall GWP of that cement, whatever it was before. Say like if it was 900 GWP and it drops 10%, and it's now 910 or 810 kilograms per cubic ton. So you'd have to figure out like world cement production. I don't know what the tonnage is, or U.S. production is. What are we looking at? Is it 400 million ton? I think.
Yeah, 440.
Yeah, 440 million tons. So a 10% reduction in that, basically overall from the old cement.
So we're reducing 10% of the 7 to 8%. So we're actually doing all this to save 0.7 to 0.8% of the overall carbon footprint, correct? Less than 1%.
Globally.
That just seems illogical to me to make a change for less than 1% savings, but maybe that's such a massive amount that I can't comprehend it.
Sure. Steve, go ahead.
Yeah, one of the things, it seems to me that back in the day when I've run around and pulled a lot of industrial floors and small stuff, but 520 pounds of powder was all I would use. Now I can't get that. They say they're scared of the 1L, so they went up to 564. So here I'm 44 pounds more to get the mix that I really need. They're saying I need. So they're going up. They're going up on the mixes, and plus all the concrete's being ripped out and replaced. I mean, what are we really saving here?
You're increasing it. You're increasing it, actually.
We are. We really are. Yeah. They just can't see the big picture,
No, and the overall cements, we're starting too early into this question. It's
there. We might as well dig into it, or we may not get to it.
So like you're 520, I'm still running 520 in my 4,000 interior flat work.
Wow.
I'm not scared of it. Like I understand it, and it's a fear. So, man, do we want to jump right in and start pounding the people that created this mess right away?
Go ahead, Don.
Oh yeah, let's call them out.
Don, go ahead, Don. Let's see what Don's got to say.
Only like
first.
10 minutes in.
That extra 40 pounds falls into the CYA category for the producers. That's what it's about.
Yeah. So
what is CYA?
Yeah,
for those in the back that don't know.
Cover your butt.
I was gonna say it, but I didn't want to sound like. Okay. Cover your with an A.
So there was a lot of when the 1L was rolled out. Some cement companies did it correctly. Some did it poorly. And there was this misconception in the very beginning that was supported by some professional organizations, we'll call them. We won't call out their letters right away. But they agreed with this. It's a one-to-one swap. No need to actually understand that it's a different material. It's new. It's not the same. Just replace the same amount. So the mixes before that they were running 520 in didn't work as well because there's water demand is different. Grain particle size is different. The overall chemistry of it changes a little bit. Admixes weren't as effective because of a little bit of change in chemistry, a change in the fineness of the material itself. So strength went down. So instead of figuring out why, you just, as a cement guy, as a concrete guy, you just throw some more cement in there. That's fine. Just throw some more cement in. It'll fix it.
That's what you
never targeted the actual root of the. You never fixed the problem. You just covered the problem. Is all you did.
All right.
Okay. Valid. All right. Anybody else got anything to interject into that? So we kind of see why we have to use it now. Now, I guess to kind of piggyback, do we have to use it? Are there options still available that are not 1L?
Right now, currently in the American producer market, no. Everybody's making a 1L.
Okay.
There's a lot more people importing right now, and that's a volatile market, right?
Yeah.
Tariffs, there's multiple things that could affect that. So affordability is going to become a concern if too many imports come into the market.
Sure.
But like Sam said, there's some producers that started in 16 when this first really coming down the pipeline. A plant an hour from him makes the cement that we utilize for a volumetric, and it is some of my favorite cement to finish. I mean, and it's a 9 to 10% 1L. So doing it right with 1L is possible. The import market's going to drive prices, and if it drives prices on the import cement, then eventually the native or the manufacturers in the U.S. will start creeping theirs up too, just because there's money to be made. So
valid point.
There are still a few older cement plants in the U.S. that are making a 1-2, and we want them to keep making 1-2 because their 1-2 isn't that good to start with. So we really don't want to make in 1L. And
thank you for bringing that up, Sam.
Yeah, throwing them under the bus already. Here we go.
That's good.
So the finish mills. Okay, one of the things with 1L. So the set time is slower than the traditional 1-2. And that was one of those things that everybody started complaining about up front, like back years ago. So, hey, if we grind our cement finer, it'll set faster. Okay, they started grinding their cement finer. And then there's a whole bunch of other problems that creates. But for those older plants that are online that are still making like a marginal at best 1-2, they didn't have the capability to introduce that finer grind. So thank God they're not making 1L.
Okay.
So in our backyard here, Heidelberg Materials is still producing type 1-2. So we have been very, very fortunate. We have a pocket right here. And I believe Keystone as well is still producing type 1-2 in Lehigh Valley in Pennsylvania here.
Okay.
Yeah.
So it is out there.
I didn't say Keystone in my thing, did I? No, I didn't call them out.
Well, then the coast will have some 3 and 5 also for airborne sulfate and things like that. That type L just doesn't stand up against. So a lot of their structural stuff on the coast is still using type 5.
Yeah, if you're making cement close to, like, I know California, it's big out there. They're still doing a 1-2-5 because they need that sulfate, that increased sulfate resistance from the type 5 because of the salt.
Correct.
Okay, well that's pretty straightforward now. I guess I understand that a whole lot more. So is it here to stay? Is there do you think we can reverse this? Is it something that we could present? Who would we even present something to if we, to try to get something changed and using it? Or is it just something we're going to have to deal with and figure out how to do it?
Then I gotta stop.
I'd suggest going for option 2 because even if you pull off option 1, it's going to be years from now.
Sure. And what would that take? What would that take to try to petition to get something like that? I know Don and I have talked quite a bit about this, and it's going to take, or some suggestions where the DOTs and things like that saying we're not going to use this anymore unless, things like that. Are there other things that would have to be on board to make that, come to fruition?
There's already initiatives on the table that have been stayed by courts to decrease the carbon footprint again. We haven't got our hands quite wrapped around this yet, and they want to knock it back again.
No.
So I don't think. There's some crazy stuff out there that I've talked with some other people about that's coming down the pipeline to do that. But luckily they got to stay in a hold put on it for now until we can get a grip on this. But I don't see it going anywhere.
Sure, and it sounds like maybe the other way, especially with Europe already being on the higher end of that too. So
Rocky, think about this as well. If they were to change back to 1-2, they would have to explain why they changed back to 1-2, which would be a liability issue. So then it would get back into who is responsible for all the failures that we have seen from this.
Yeah. Pardon all the smiles.
Valid.
The AI is watching us right now. It's like, oh.
Oh, everybody's laughing. Why are they laughing at that statement? Truth, baby.
Yeah. Steve, did you have something?
It's
Go
not
ahead.
going away.
Yeah,
Go ahead,
yeah. One of the things I was going to say, and Sam, you send back to 520. So, what's your target on your limestone?
On the
On
limestone
520.
in the cement.
Yeah. What's your target?
Anywhere I've run that same mix design anywhere from 8 to I think 13, 14%.
See,
I was going to say, I think we've run at 14.
There's a lot of other stuff that comes into play with it, though. It's not just there's my aggregate blend, there's my water cement ratio, there's my admix packages. There's a lot. It's not. I don't say it's not complicated. It's not hard once you understand it. It really I don't think is. Once you understand what it is, what's going on, it's not as hard as people try to make it all the time.
Mike, go ahead. Do you have something?
I think on. Well, sorry. Go ahead, Don.
But it is also so variable. I mean, from one day to the next, from one load to the next, you can find anywhere from 8 to 14% on a day, and that's a problem.
That's not so much. There was some misinformation thrown out there early on. Like, if there's anything in any truth, the cement plant itself is putting out a pretty consistent products. The plants themselves, the ones that are more modern, not some of those old crap bags, but the more modern cement plants are putting out a pretty consistent product. There's a couple theories out there of the limestone is a lot less dense. It's a lot finer. So during transport, to move from where it's in, like your rail car, your barge, your pneumatic bulk or delivery truck, it can settle out and do different things. So like what's coming from the plant is one thing, but there's some theory out there that by the time it gets to the ready mix guy, depending on the amount of handling, it can vary a little bit more.
Yeah.
Okay. So it's not, nobody's actually been able to prove all that yet. We've sent some daily samples off to some guys, and they're working on that right now.
Ben, go ahead.
Yeah, so that was one thing I've been curious about, since from my understanding, the Blaine fineness, or the fineness of the granulated limestone, as it goes into these silos, is it possible that there could be clusters of it in more areas? Because for us personally, we've done projects to where it seems 3 or 4 trucks are fine and 2 are not. And I just can't figure out what else it could be. So if there's clusters of this stuff in certain areas, could we be getting more or less in one truck or another?
It's sensitivity and need for water is very important. So if you got some good old ready mix drivers who wash down their truck really good, you might get a couple great loads in a row. Then you get some new guy who doesn't care how crappy this truck gets, and we may not have as much water in there as those other couple guys, and that will make a difference. Okay. It's
yeah.
That's
a definite. What Sam brings up there is huge, and then it'll also swing the other way on you, on the ones who aren't actually discharging well. They get back and they did a really great job of washing down, and they didn't discharge back when they got back in, and they just drove up to the tower and hey, load me up. Yeah, well, there's an extra 30 gallons in that one. You weren't counting on that, were you? And so, and it is more sensitive as far as you actually seeing those things a lot. That'll kind of go in. We can get in a little deeper here. I don't know if we want to dive off that, but it's that slippery slope of how deep do you want to get into this. And I think, Sam, if we kind of explain some of those things as far as the sensitivity of the water demand and how it actually is affected as far as where we at, why is this exactly what Ben, brought up? But it's actually something that they haven't seen before, but it's because of the finer bling, right? It's because of actually having limestone in there. The limestone does not act the same way that the clinker does. It doesn't have a chemical or a mechanical way to hold water. So it actually it's very different. And so how that is interacting, Ben, is what you're seeing. And having a dry truck versus one that's washed, all of those things all matter.
Okay, that's good. Mike Griffin, did you have something to add in there? You had your hand raised, and Mike?
I do.
Yeah.
I got a question on the comments section.
All right.
I think it's falls right in line. Hey, Mike Murray asked, had any studies been done before this was accepted? And how did that affect the aggregate to paste bond, especially at the service? I was asking about what studies were done before all this was accepted, and how does that affect the aggregate to paste bond, especially at the surface, if they did those studies?
All kinds of laboratory studies were done. Laboratory. Yeah.
Not real world. I'm assuming they
Not
try
field.
to have a real setting.
And that would make sense, right? Because that's kind of what we're seeing. And I've noticed it personally myself. Indoor slabs, if you can control the environment, it's not much difference, really. Timing's the bleed's different, obviously, but as soon as you incorporate wind or sun or both, things change real quick. So,
and that's you just hit on the big one there. The bleed's different. That limestone. Remember they're grinding it finer to make it set faster. That's the clinker. The clinker's really hard. The limestone's soft. So the clinker's getting ground finer, but it's also pulverizing the limestone finer and
much finer,
way more finer than the actual cement. By the time the cement gets run through the mill to get down that to the blade that they're looking for, the limestone has just turned to a powdery poof of whatever the hell you want to call it. So it's
and
those small particles are not only absorbing the water, but they're also slowing your bleed rate to the surface.
okay.
Right. And Sam, if we put a little bit of math to that so that it can actually put a picture to this for everyone, when that's happening, you're looking at like a 50+% increase in surface area, Rocky. Okay. And so if we're talking, so I like to simplify it down to how we like to, if you're looking for a low shrink mix, or if we're looking for those type of things, we want larger aggregate, right?
Sure.
So that we have the ability, we can actually decrease the amount of paste. We can, lower our water cement ratio. We can do all those things in a very healthy manner. However, now if we're going the other opposite direction, what's happening is that you're actually running out of water, right? It's actually being able to be absorbed. Your water demand is higher. So that is why we see these types of things.
All right.
Yeah. And limestone is, like, for the parts of the country who are using limestone as their aggregate, it's the same aggregate. It's just powdered down into little tiny pieces. So it's little tiny pieces of rock. And if you're a ready mix guy and you're listening right now, and your aggregate is dry going into the concrete plant, what do you do to the moisture cut? What do you do to the batch water you're putting into that?
Okay.
Yep. We up.
Mm-hmm.
So that's, as a finisher,
that in the limestone. They haven't accounted for that in the limestone because of water cement ratio. It just was part of the cementitious makeup, and they never considered that what the water demand of the clinker needed to increase because of the addition of the limestone by 2 to 3%. So everybody was chasing it from the start. And that smaller particle size, it takes the water faster because there's more surface area. So that combination made for about 90% of the evaporation issues.
And just like that, just like the limestone in the aggregate, once it goes into the limestone that's in the powder that's in the cement, it's not there for the cement to hydrate either. So you see strength's not as great because the limestone is robbing water away from their limestone. Okay,
so as a finisher, what I keep hearing is, send me a 7-inch slump, send me a 7.5-inch slump. Does that nullify it? Does that make it better?
Nope.
I mean, Just
your
add
ready mix
more
guys are going to
water.
be scared of it.
Yeah.
If you call and ask for a 7-inch slump, they're going to tell you we can't send it out that way. Or
Right.
if they do, it's still going to be a 0.44. It's just going to have 48 ounces of water reducer in it. So your water cement ratio doesn't change, just your workability does. And everybody sees it hits the ground, and you got a 15-mile-an-hour wind, 20% humidity, direct sunlight, but you're pouring in an 8-inch slump. You're like, oh, we're going to be fine.
Sure.
An hour later, you can't poke your finger through the top,
right?
Because it's evaporated so fast. Yeah, that's where working with the producers starts to get really important, because they're scared that if they don't put a mix out that breaks, right? Break is the biggest thing they worry about. That you're going to come back.
The only thing they worry about. They don't give
Sure.
a crap about anything other than it making strength.
Sure.
So, and as a finisher, you don't, when you're out there in the middle of it, you don't care what it breaks.
Right.
You want the balance
I want
between
it to look,
it's
I
going
want
to
it to
meet
finish
strength,
right.
look good, and do what it's supposed to do next year.
Right.
So,
yep.
Fighting that fight's really important.
Ben Bass, you have a question?
Yeah, let's go ahead and like crush the conflicting stuff out there of you keep hearing, well, you need to use less water with type 1L. You need to use more water. So which is it? And what there's a difference between a 4, 5, and 6-inch slump of water compared to admixtures like water reducers. So what exactly are we looking for here?
Oh, I don't even know what it is anymore. But before, a 0.28 used to be the absolute possible minimum that you could make concrete work at. And anything over that was called water of convenience for finishing. That number is not 0.28 water to cement ratio anymore. It's a lot higher because of the limestone addition. I don't know if anybody's actually done that study yet or not, to what it actually takes to hydrate it. But contrary to popular belief, concrete cement does need water. It's a chemical reaction. If it doesn't have enough water, it's not going to make the reaction correctly. Yeah. And that's science. You can't, it's just science. What do you say?
Sure.
So we need more water in this new cement as opposed to the old type 1-2.
But that's ready mix
then.
guys who are scared to put water in it because when it first came out, they treated it like something else. It's not 1-2. You can't treat it the same. It's different. If you treat it the same, you're going to have problems. If you embrace it, love it, put some water to it, it'll treat you good. I mean,
some are still doing that. There's some producers in Pennsylvania that refuse to go above 4.4. Absolutely will not ship the material. And so what do? They spike it up with a bunch of water reducer, and that blows up along the way. And then the problem is right back in their face again. So
and bringing in water reduction to it as well. There's the technology of the 1-2 or the product of the 1-2 and the switch to the 1L happened so fast. Admix guys were caught with their pants down.
Sure.
I discussed one of those slabs that we had issues with, and it was an old corrosion inhibiting admixture that had been around for years, lots of success on bridge decks and things like that. We used it with a 1L on an 8-inch slab, and anything that takes the free water and uses it for other things, corrosion inhibiting, porosity inhibiting, internal curing, anything that steals your free water is going to play hell with a type L cement.
Oh,
there's old water reducers out there that they'll work, but the more it takes more of them now to make them work. When you get up over a certain amount of those in there, they start to retard the set of the concrete. And then
we'll get into this a little bit more. I need to stop you there. Just a quick answer. So internal cure takes away from the water.
I think anything that utilizes the free water.
Okay.
No, well, internal cure doesn't take away. It adds.
Okay. Holds the water.
So it adds more water
it's a donor water.
What's your internal? What are you using for internal cure? There's a
silica.
So internal cure to me is a lightweight aggregate that's been saturated that's going to release the aggregate, or some of the other. There's some other chemicals out there that'll actually absorb water. You get them wet, and then they release the water. That's an internal cure.
Okay, so so let's stay away from the chemical. Let's try to. So there are aggregates that you can put in it that will act as an internal cure.
You can grind up some clay pottery, put 10 pounds of that in, grind it up the same way as you're grinding up the Portland, and you'll have all the water you need. It hangs on to water forever.
Okay. That sounds like a pretty cheap internal cure.
Yeah,
it is cheap.
The DOTs have been using lightweight fines for a while, even before the 1L came out, because bridge decks are important. They're expensive. You don't want to go replacing them all the time. So they were looking for solutions a long time ago for internal curing that would help any shrinkage cracks, period.
Mm-hmm.
And so started using lightweight fines are actually pretty awesome because they'll spread out through the whole load of concrete. They don't change a whole lot of finishing characteristics, and they hold a lot of water.
All right. Well, that's it. Bobby, did you have a question?
What are there admix designs that are really terrible to work together with this Type 1L? Because I've seen sometimes I'm going to use an example, if we're pumping a slab and it's just to say there's Super P, accelerator. We usually run an accelerator in this time of the year. Sometimes we've seen it did an opposite effect type of thing. So are there some things that I need to watch out for? Because we deal with so many different suppliers because we work with a lot of different companies, so I don't really have my say-so on, hey, we're using this company and we're using this admix. We just show up and the admix that they give us and the companies, what they order, the submittals, that's what we go with. So there's some things I need to be on the lookout for moving forward to know, or at least to be able to have the conversation ahead of time.
Steve, did you want to throw something in there real quick, Steve?
Yeah, I just think you need to do away with the chemicals. The best concrete in the world is rock, sand, cement, and water. And I can prove that. I got data to prove that.
Yep.
You want to put all this stuff in there, and they do have adverse effects on each other.
Sure.
Some of them work against each other. They're really hard on the finisher. What's wrong with rock, sand, cement, and water? What's wrong with it?
That's why I asked if there was other, internal cures that weren't chemical.
Don't get me started on chemicals. I think chemicals have the right place. In certain places, but not in the floor.
Ready mix guys are scared it won't hit 4,000.
Sure.
Well, if you look at reports, Sam, most of them send you a 4,000. They break at 7. That's the worst thing in the world you could have.
That's a high. I would rather have 3,900 than 7,000. 7,000 is more problems than 3,900 at a 4,000.
I'd rather have a flexural strength of 600 and a 3850. I got the best flow in the world, and I can take you to 28 states and prove it.
Absolutely, Steve.
I had that conversation with a ready mix supplier last week who was trying to give me a 0.39 water to cement ratio on interior flat work.
Sam, I'm pouring a 900. I'm pouring one right now that they signed off on it, but it's 900 pounds of cementitious material with the 0.39 water cement ratio.
What?
Yes.
What?
Yeah. Oh, yes. So I told him, I said, you can bring the owner up here and you can show him. I got a 10,000 PSI slab. I got a shitty floor.
Yeah, 100% you will.
Say that. I
Guaranteed.
You will have down the long road after it starts to crack and curl and do all kinds of crazy shit. And you're long gone by then, so you might get away with it. But that floor is going to curl. It's going to do all kinds of weird things.
Sam,
down the road.
You know good and well they're going to come back 10 years and say it was the finisher's fault. I started in 1972, and I'm still getting blamed today.
So to answer Bobby's question, so admixtures that really don't play well.
There is a tipping point with these water reducers. When they start flooding water reducers in, it's just a sign of a bad mix to begin with.
So
and it can only go downhill.
There's multiple different chemicals too. So there's lignin-based, there's naphthalene-based, there's polycarboxylate-based. Remember that big word, polycarboxylate. All the rest of them suck, except for polycarboxylate. If you have to use one, polycarb is the newer generation of admixes. They don't retard the set if you put them in.
But don't overprescribe it.
Yeah, if you have to use it wisely and don't go crazy with it.
But Sam, they do produce air. And the reason
when
I say
overprescribed.
that,
When
they
overprescribed,
produce air.
Steve.
Yeah.
The reason I know they produce air, they tell me they don't produce air. If they don't produce air, why do you make a defoamer?
So they're
You know,
because you can use them in exteriors. Like one of my favorite products has a defoamer in it, but I'll use it inside and outside. So if I have air and I'm trying to purposefully air and train some like exterior structural stuff where I need air, but I need it to be a higher slump, and I use one without a defoaming agent in it, and it comes out and I shoot it at a 5, I put my super in, it'll blast it up to an 8 or 9. Truck's rejected. The defoaming agent keeps it around 5.5, usually won't go over a 6. It keeps purposely trained air in check, is the best way to put that. It won't necessarily add air and trapped air. It may add some entrapped air into an exterior floor slab that doesn't have any air, just because of the mixing action of the concrete. If you take that air test 5 minutes later, say you took an air, like testing lab guy finally waddles his big ass out to the job site, gets a sample of your interior slab, takes the air right away after you just put some super in and got done mixing it up, and comes up with like a 4.5. That was just from the mixing action and the more thicker way the polycarboxylate does its thing. If you sit and like wait 2 minutes, 5 minutes, and take that air test again, you'll be back down to like 2.5 to wherever it was before.
Yeah.
It's not so much that it's adding air, it's the mixing action that's entrapping some air that's being held on to momentarily.
it's like pouring a Pepsi Cola in a glass when it fizzes. So if you take that wheelbarrow and set it over for 5 or 10 or 15 minutes and retake the air test, you're going to be completely different.
Sure.
100%. So like
Yeah.
the stuff you're actually putting through the pump or putting down on the floor and going back to finish later, they don't have no air in it.
Emil, did you have a question?
So, with all respect, guys, there's a lot of fancy words getting thrown around here that me as a concrete finisher doesn't understand. So what we do know is that we have a product that guys are out there putting their livelihoods on the line. You know, Ben, myself, doing this kind of work, especially the decorative market, which is taking a hammering, you know, from all of this. What is the solution? What do we do moving forward before it takes a toll, especially on the decorative industry? It will put a number of people out of business if this continues status quo the way it is.
So number one, we've heard already, add more water. So that's across the board.
So
we need to convince our batchmen that water's not a bad thing if we're using 1.0.
It sounds like Sam has a solution. You know, as far as upping the water cement ratio, reducing your chemicals. This has been on the market for a number of years already, and we still don't see those solutions. So what does it take to draw awareness to this so that those solutions take place?
So work with if you have a favorite ready mix producer that you like working with, work with them. Tell them, get on them. It's not I approve a small fraction of actual mixes that come across the first time. 90% of what comes across my desk gets sent back with a note that says try again. It's your concrete. You're purchasing that concrete. You have every right to not have to use crap.
We are finishers. We are not chemists.
That's where, God, this is the hard part, because the ready mix guys, just some of them work, some of them know what they're doing, and some of them don't. And you get those ones that don't, and they're so bullheaded. They don't understand the concept of, because they've grown up in the world where water is bad, and then the lower the water cement ratio, the better your concrete. And it's because that was a different cement. It's not the same cement.
Yeah. Steve, go ahead. Did you have something, Steve?
Yeah, I got a lot to say. But listen, why do we have to be a technical expert to pour concrete? I mean, what about the old boy in the morning that's getting up, gets out of bed, gets in his pickup truck, 2 trowel machines and a wheelbarrow, going out here and make a living for his wife and his 2 kids, and he's fighting this battle and getting his butt handed to him.
Right. Yep. We all get that. We all get that example. We get that. That's what Sam's trying to say, is that it's not. It shouldn't probably be the contractor. Your batch man should kind of be the chemist. You should be able to call him up and say, "Hey, this is what I want." And when you're looking at it, that kind of thing, I think is. Am I wrong in that, Sam?
No, you're not wrong. And I know Zach. The thing that Zach and I are working on for some other group is that's going to be, I think, probably one of the first things out there published to say screw ACI and their water to cement ratios.
Yep,
they don't work.
We did bring that up in 360, and then we are trying to get the water cement ratio to 0.50 to 0.55. So that was voted on in Chicago.
Yeah, that was on 302. Yep, absolutely.
302, 0.50.
Yes, sir.
I brought it to Pat Harrison.
You have to get the ready mix guys to agree to that, though. That's where the hang up. The information's starting to get out there, but the ready mix guys just are putting up a roadblock of, hey, yeah, that's great. I need my strengths at 4,000. So you're getting a 0.32 water cement ratio and a bunch of admix. You can't finish it? Too bad.
But if they appreciate you and respect you as a customer, you go sit down in their office and say, hey, let's never stand on a driveway with the top popping off again. And if we do, let it be my fault. I would like to try this. I would like to get to a 0.48, a 0.50, and let's run a few out and see how it goes. And if it's working for me, then you can use it for your other customers. I mean, if we can be proactive and never have to have the conversation, then I promise it will end a lot of this finger pointing, because if we assume liability as contractors, then they're just going to say, hey, it didn't work. What are you going to do next?
You have the liability already,
right?
So might as well make it something that's going to work.
Sure.
Like you're the one. You guys are the ones holding the bag already. At the end of the day, they're coming
Absolutely.
at you guys first, not the ready mix guys. Then you're going to complain to the ready mix guy, but they're coming to you first. So you might as well take the responsibility you're already assuming and run with it.
Sure. Ben Bass, did you have something?
Yeah, so I shared with you guys earlier, if you guys saw that. So our local ready mix just last week put a slideshow presentation together how their QC guy was saying to them that we need to stay on the low water cement ratio side. So as a concrete finisher, what am I supposed to do? Like I try to share all this information with them, and we're kind of given what we're given. Now they will work with us and make adjustments, but if the whole company's under the impression that, hey, we need to lower our water to cement ratio, which obviously we're going to replace that with chemicals, we're kind of given this stuff and we don't really have much of, I can't make them change their procedure and their formula, I'm sure, just by saying, hey, I want a higher water to cement ratio and then back it up. But I guess at the end of the day, they're not going to back it up anyways, because if something happens, we're going to be standing there held responsible just like we are now.
It's the conversation I had with the supplier last week, because all they care about is strength. That's why they're lowering their water cement ratio, because they care about it made 4,000, or it had 4,000 and it's 5% air to make requirements.
Right.
I have to care about it cracking. I have to care about how it finishes. There's a lot more than I could care less about strength. Like Steve said earlier, I'd rather have it not quite make strength and make it 7,000. I need properties to make it not crack, not do weird things, and that's the water part of it all. And that's the conversation you had. Like I had the conversation with them. It's like, look, all right, I'll take your mix at a 3.9 when it does this, 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 and this, which I know it's going to. We're gonna be standing out on the slab arguing about this crack, and I'm gonna say I told you so, and then we're gonna tear it out, and you're gonna help pay for it.
Mike Griffin, do you have something?
Yeah, I've got a couple people in the comment section asking the same thing.
Sure.
Start off with Sean Stahl. He said, we need a better explanation. We're finishers here. We need a better explanation of what more water even means, because we're being told the exact opposite for so long.
Right.
Oh, somebody just
so me. I saw this comment. I tagged
I feel like that's too broad of a claim for a delicate change. So he's asking, tell me exactly, We need a better explanation of what more water even means, because we're being told the exact opposite for so long. What water cement ratio do you mean?
Sure.
Before chemicals.
It should be bumped up to what?
Before chemicals,
So
right? Yeah.
Sam, go into that. So we need to actually talk, guys, about what the guidelines are within 302 and others.
Yeah.
For what the water slump is supposed to be before adding the mix, the admixtures, Sam. And so that
it gets tricky because the water cement ratio for me here in St. Louis is maybe different for you, because your 1L is going to be a little bit different. It's going to be the limestone. Our limestone quality here is awesome. Our 1L rocks. It just depends on where you're at in the country, and we see it all over the place. Like the harder limestones, you can get away with not as much water. You can run a 4.6 or something like that, or on a flat work and not get hurt. There's other places where you got to have a 5.3 minimum for interior flat work. The problem then therein lies with some of the rules. There's rules. The rules are old and outdated.
Yeah.
The ACI says for a freeze thaw durability, I can't go above a 0.45. A 0.45 on a high limestone, super fine, bad soft limestone mix is going to be terrible. It's going to crack. Correct. It's going to open up. It's going to the surface is going to dry off. And you need to be at probably about, so I guess the best way. So if your ready mix guy, before the transition to 1L, was running a 4.5 on his exterior concrete, now he needs to probably be at a 0.48 minimum. Like add 0.03 to whatever water cement ratio you're using before, and it may not be right, but it will get you to a safer, more friendly version, and you have to play with it from there. But that's the automatic is probably a 0.03 addition.
Steve,
but then that's a strictly water, right? That is correct. If you're getting there. So how do we get our ready mix to get there with water before adding the admixtures? Because I think they're adding admixtures and then getting to those numbers.
Because you'll have a 0.38 show up and it's got a 6-inch lump. You know that ain't right.
Right.
So one thing, a lot of these engineers are designing slab on grounds out of 318, which is structural, which is a really low water cement ratio. So they need to go to 302 or 360 when they're designing these slab. They're not structural, and for the outside stuff, decorative stuff, that's not structural. So the engineers have got a role in this too. But what I tell the ready mix guys, if you don't, just bring me the concrete and we'll put the admixture on site. And then I'm going to get all the water that I'm allowed. And I might not need but a teeny bit of that admixture to get there. But I want all the water that's allowed to me without exceeding the water cement ratio. We've got to have more water in this 1L cement. That's the whole problem. Yep. And the finishing aids and everything else we're throwing on this stuff is 90% water.
And that's what I was going to suggest.
If you're not at a 3.5 inch is what you're looking for before any chemicals get put in. If you don't have a 3 to a 3.5 inch lump, you're, first of all, as a ready mix guy, you're not that smart. I'll tell you right now, all you guys can be mad at me, ready mix guys that are listening can be pissed. You're not that smart. Because what's the cheapest thing going in your mix design? Water. Why not put in, if you're going to send me a 0.45 water cement ratio mix design, I want my 0.45. Don't have a truck show up at a 0.4 and a crap ton of chemical in it. I want my 4.5 with water, and then you work on your admix after that, because admix costs money. Water's not free, but I'm going to say free. Water's free.
Sure.
Your admix costs $12 a gallon. You're killing yourself by not giving me the water I need anyway.
Emil, did you have something?
With the 1L.
Emil, did you have something? Yeah.
Yep. So, Ben, you're working with ACI 310 right now, correct?
Yes, sir.
So isn't this something that on a decorative part that we can try to address within 310 as to a proper mix design, as to what Sam's saying, up the water cement ratio, and give recommendations on admixtures, etc., to at least give our ready mix suppliers a place to start.
We absolutely can. We can put together a tech note specifically on that. But those types of things, right now, that has not been under 310's purview, because we fall under, we're the decorative side of, you've got 302, you've got 360, you've got it depends on what you're doing, right? But we can absolutely look at putting together a tech note on that, Emil.
And that's what I was kind of getting at, is creating a cheat sheet. Like for us, the cheat sheet, when we're going to do something away from our normal work area, we look at the mix design, and the first thing we try to do is get their water reducer cut down, if not in half, as close as possible, and tell them we want our concrete delivered without the trim water. If they have faith in their mix, they should be putting that water in when it's batched.
Quit holding 30 on me.
Get them to do those two little things, you'll notice the difference. You're getting a 5-inch slump at a 0.46, and it's quite a bit different. It's with real water, and that speculation of whether or not they got there using water reducer, it kind of goes out the window.
What's trim water? That's a term I've not heard before.
So it's essentially, that's their CYA water, right? Okay. That's if a driver left a little in a drum and they batch what they should have batched by proportion, and then he looks in and it's a 8-inch slump and you're pouring curb, well, it's because they had that leftover water. Now they trim it so they can make adjustments either at the plant before it leaves, or when you get on the job.
It's easier to take it out it's easier to put it back in like that way than it is to take, once it's in, it's in. You ain't taking it back out.
Sure.
So it's easier to hold something back.
So they naturally want it. Yeah, that makes sense.
Yeah.
Why they would. Okay. Got it. Emil, did you have a question?
So I sat with an owner of a ready mix supply company last year who had absolutely no idea what 1L was. So there's still a lot of people out there who need to be educated.
Sure.
And we need, so by putting some type of documentation, and I'm calling out both you, Sam and Ben, on the industry. Like, we need some type of a document to produce to these people so that they know where to start.
Yeah.
There has to be a starting point regardless of where it is. But if we do not have that, we could just throw our hands up and scream bloody murder.
Sure. Mike Griffin, do you have something? Okay.
So it's always been there as far as guidance goes. Okay. But right now, so the old guidance for C150 is 4-inch water slump before you put in the admixtures. That's 302. That's 302 8.4.4.4 whatever. I mean it's supposed to be a 0.47 to 0.55. Supposed to be a 4-inch water slump before adding any of your admixtures. I mean, there's all the things that are all in there that are friendly to slabs. Okay. We're talking about slab technology, not structural. Okay. And it gets into what Steve brought up earlier. So what happens is that the ready mix guys so lean towards 318 and the low water cement ratios, and they're bouncing on that side of it. But the thing is that I saw a comment earlier, guys were asking, well, why would I want a lower break than a higher break? Why do I want? Because we need ductility. Okay, we need survivability and we need durability. All right, we're selling a durable product that's meant to be there for generations. It's supposed to be from cradle to cradle, not cradle to grave. Okay, it's from the time that it's this man's baby that I made it for till the time that he sells it and someone else is the new proud owner of a slab. Listen, if that's in 7 years, they shouldn't be having to look at fixing joints and tearing stuff out and doing replacement and repair. I mean, Steve Lloyd can preach on this. This is getting into, give me good concrete, give me that neat mix design, and quit selling me chemicals.
It's not.
And that
it's,
comes from.
It's not. It's really not rocket science. It's pretty basic, and we need to use common sense. But the limestone is really giving us a weaker surface. According to the abrasion test we've been doing, we're down pretty bad on abrasion resistance with the limestone because it gives us a weaker surface. So, go ahead, Steve. I'm sorry.
Interior, exterior surfaces.
I'm talking interior.
How you curing then is my question.
Water
because
cure. P&A Ultra Cure blankets is the way I've always done it. The other the outside stuff I like. If I can use water, I will. But a 25% solid is pretty blame good.
What abrasion test are you using?
What do you call it with the wheel?
The British or the
What do you? I forget. I got the name over here, but I had to buy it. I bought mine. I had to get it in England and had to go to England and get trained.
So you're using the correct one. The correct one then.
Yes.
Is what you're saying.
I forget the name of it. What's the name of it, Sam? Come on.
It's a BCA, British Chaplain Abrasion.
Yep.
Chaplain. Yep.
And that is the right one, because that is actually the in situ, which is what matters. I don't care what you get in the lab, what was produced in the field. Okay. That's what matters, Steve.
And the results we got, I mean, they talk about internal cures, this, that, and other. I mean,
so are you running straight cement with that, or
we ran straight cement and had we ran straight cement. We would always run straight cement. All right. And we got great floors. We might have as long as I can get a 600 flex, people put too much in compressive strength. I mean, compressive strength BS as far as I'm concerned.
I would, man, if it was my concrete, I'd throw a little slag in there and you'd be surprised what happens.
Look,
Don's been saying that too. So
it's slag and 1L for cement like back in the old days, slag slowed your set. It did all kinds of stuff and people didn't like it because it made the concrete set slow and all this other. Man, for 1L cement, it's like magic. You'll get similar sets to your old 1-2 concrete. Mm-hmm. You'll get bleed again because slag counts as a cementitious material, yet it doesn't absorb water like other powders do. Mm-hmm. So it gives more of that water to the cement that it needs.
What about
it does a bunch of stuff.
What about a little Nucium?
Nucium? Is that
it does hydrate.
Yeah, that is. I think that's isn't that their blended? That's who's it? Is that Bootsy or Wholesome or Amrise is blended?
That's still it.
Blended. Yeah. That's slag. That's slag cement.
That's it.
Slag,
that's good stuff.
Yeah.
That's good stuff.
All right, Ben Bass, did you have something?
And you eliminate a lot of the ununiform, blotchy colors shades that you see in slabs with slag. Yeah. It mellows things out.
Okay.
I mean, we have some slabs we did here about 3 years ago. They look like they were done in white Portland. Okay, totally uniform and held up like a rock. So I'm with Sam on this one 100%.
For me, that's like Frank's. Put that shit in everything.
Yep. But don't run over 25% with it though.
Yeah.
Because then you're using up a lot more water.
Mm-hmm.
All right. Ben Bass, did you have something?
I do. I don't mean to kind of change gears on you guys. I think this is a critical question for the concrete finishers because I think that's most of the people watching this. If you guys don't mind, I think this is important. How should we be placing, finishing, and curing exterior and interior concrete successfully with long-term results differently with type 1L cement compared to type 1-2? Follow-up, does that change as the limestone content increases, say from 9% to 12%, or do the finishing practices stay the same?
Now, are we
curing committee?
Just placing?
You're taking this one.
Just placing or all the way from placing to finishing?
So as a concrete finisher contractor, how should we be placing and finishing and curing this new concrete compared to what we've always done? What do we need to do different to be successful?
Add water. We got the water.
So
we could add slag to the mix, and that's going to help too, right? So there's two things.
So I'm gonna get on my curing soapbox, okay? And this is something I'm very, very passionate about, Rocky,
Sure.
because concrete has the life cycle of a human being. All right. And from the time that it leaves the back of the truck until the finisher actually does something with it. Okay. And when I say that, I'm talking the first time we're actually beginning to do something, that concrete is actually in the NICU. Okay. So it's a premature baby, and you've got to take care of it correctly. The most important function in curing is actually in that time period. And it is actually that initial curing phase, from the initial to the intermediate curing, that is so important. So initial curing is from the time that it leaves the back of the truck until we're actually doing something with it. Intermediate curing phase is between when we start doing something with it until we actually apply final curing, when we're done. Now, one of the things that you'll recognize is that, and Ben, you absolutely nailed it, because from the time from that 8-ish percent up is actually when the sensitivity ramps. Okay. And that is where you'll actually see more of the skinning, which, those go into, we did some Klinger and we did a couple years ago, I guess it was January. It was about finishing 1L. It was in Concrete International in January of 24, I believe it was. That those couple of articles that were way back there, with the 1L, if you were putting on the standard evaporation reducer, okay, evaporation retard, then you'd have to put it on every 12 minutes, and that still wasn't good enough. Okay. It still was skinning. And so that clues you in to the sensitivity of it, because if one of the things that I always try and direct to is that if you look at your cement cert and you go over on the right-hand column and you look at that initial set time at 70 degrees and 70% relative humidity in the lab, that's your set time. That's your initial set time. All right. If we're putting trowels on it or it's Skinner, you're walking on it before then, you didn't do your job as being a good nanny. You already lost it, and it's your fault. Those are the things that I try and draw people's attention to. And that is the understanding, that we're in a nursery at that point in the concrete's life. And as it goes through, if you take care of it correctly, you don't have what I call shaken baby syndrome with the concrete. Okay. And that's, so you've abused it, and, oh, well, we've got problems. Yeah. It's never going to be a Rhodes Scholar, or it's never going to be an athlete. We're going to have problems, right? Why? Because we didn't take care of it early. If you raise a child correctly, then you're not going to have these situations, right? And that is, I try and dumb it down to that level so you can understand the sensitivity of it and the reality. Don, Sam, you guys are, you guys are understanding what I'm saying, but that is, Ben, you were raising.
Yeah, I just want to make sure. So as far as like placing and finishing, nothing is changing between our old cement and new cement other than controlling the evaporation. That's it.
Rapid moisture loss at the very beginning is going to set the tone for that concrete's life cycle. If you do not control that early rapid surface moisture loss, okay, that is what creates the skin. That's what traps bleed water. That's what actually exacerbates and gives a higher capillary action, right? And so when all of those things happen, if you don't control that early moisture loss, that's what sets off all other problems.
And at that time when it's happening, you're losing free water through diffusion.
Correct.
And evaporation.
Yeah,
and that's
you don't have as much anymore because your limestone is absorbed and those fines are holding your bleed down. So I guess the easy part is, before you had all kinds of bleed water that came to the top, and that kept your surface moist. The fines are holding your bleed water down, so it can't get to the surface as fast. So your surface is drying out, and then you lose that ability. It loses the ability to actually bring the water up then at that point.
And Sam, we all kind of know the answer to this question, but how's that show itself? In delamination, right?
Yeah.
Yes.
So everybody
absolutely.
that is getting on posts saying,
Sure.
"Oh, they threw water on it. Oh, they threw water on it." There's a pretty good chance the evaporation rate was just high,
No.
and the bleed water
Correct.
was trapped below the surface.
Surface falling because the top dried out, so it doesn't have
Yep.
structural integrity anymore. So you have freeze-thaw damage. You have all these things that are exaggerating themselves more so now than there was before. So that's why
Correct.
you see all these posts on the thing of, my whole top popped off. Yeah, it dried out
Yeah.
probably. You did.
No,
Nine
yeah.
times out of 10, they may not have actually thrown in the first, learn how to finish. Stop throwing water on that. That's probably 9 times out of 10, that probably didn't happen. The surface dried out.
Absolutely, Sam. Absolutely.
And that's
Just,
why
and
just
actually-
backing,
the water
just
cement
backing-
ratio starts the curing.
just backing over a place. Once you placed, scratch it down, struck it off, bull floated it once. Just dragging a plastic membrane over it will do more than any of these silicas sprayed on it. I mean,
Correct.
a little bit of wind breaks up the pattern and leaves open holes in it. I have a project right now where they, kind of abused the day one, and the entire top came off in little quarter-size round blisters everywhere,
Yep.
just like
Yep.
potato chips. Okay.
Well, Don,
So, yes, sir.
I got a question. You talk about day one. You talk about all these evaporation retarders are 90% water. You just want water on the slab. I mean, what is the first thing we were taught as
No.
finishers not to
So-
throw?
They
you don't finish it. Never
they
finish
are
it in.
water,
You spray it
but-
down.
Exactly. You don't finish that material into the slab. You let it, it's there to evaporate instead of the water the bleed water that's remaining in the slab. You let the day
Correct.
one evaporate, and you don't touch it until it's totally evaporated. Then you can get on it.
Okay, so from an instructional standpoint on the jug, day one says you want to work it in as well as our slab saver and such. So I don't know that would be the proper product for that. Maybe a con film or something like that, where you would just spray and leave it be. Am I wrong, or
That is
because I know
the
if I've
nature of
sprayed when I've
conflict.
sprayed in this, or I've used our slab saver and didn't work it in, I'm just going to say it wasn't a good thing.
Yeah, there's a lot of terms that people get mixed up for different products that don't do the same thing.
Sure.
Evaporation retarder is your aquafilms, your con films, where it is 90% water and it leaves God, I forgot the name of the whatever kind of alcohol, and it forms this little tiny membrane on top.
Alphatic
Yes.
alcohol. Right.
That one, big
It
one.
replaces the bleed that isn't there.
Right.
Yes.
And it forms a film on top. As soon as you touch that concrete, you break the film. So if you go and edge it or do whatever, decide hey, there's a hump out there I want to get out, you got to put more down, because as soon as you break that skin, you done killed it. Okay. Then there's finishing aids. That's a whole different category of stuff. That's not the same as an evaporation retarder. That's your day ones, your other one, and some other ones. And those are designed to be worked into the surface because they're I'm talking about it and Ben's looking at me like, it's my product, dude. Let me talk about it. But, go ahead.
Well, so when you're using a colloidal like that, all right, and there are many of them on the market, right? You're putting that on there, and you do want to bull float that in. Now, can you put it on and not bull float it? Absolutely, we do it all the time. Spray it right out of the screed, and you're putting that on there. But the thing is, Rocky, is that you want to put those on immediately at placement. All right.
Okay.
And then let, if you're spraying it on late, okay, it will actually act as an it's going to actually it's going to be fire, okay, especially if you're a higher pH colloidal. All right, those type of things can you're playing with fire.
Sure.
Okay, and so those things that Don brought up before, absolutely right. Got it. You're putting, you go out there and you put on these things late because you're trying to save it.
Right.
Right. That's the whole thing. Okay, so that means you already lost it.
Yeah.
That means you already lost it. So then you're going to you're actually, if you're going to do that, now, are there ways that you can do that and save it, truly save it? Oh, yeah. But you have to do it in a very calm fashion and not the way that typically gets done. Okay. Every defect that you ever see in a slab was put there by a finisher, right? It's because we didn't get it on time. Something happened. We missed this. We didn't see it, whatever it is. And so when I say that, whoa, stop. So are you finishing that slab or not? Well, I didn't have time to catch that. Well, were you behind and were you chasing it? All of those things, what caused that?
Good.
So we want to be slow. Like I mentioned earlier, with when you're raising a child, concrete is very much, don't complain to me about the dance step that she's pulling because you're the one that taught her it as a finisher, right? So concrete is going to have that where it's going to, if you hit something and you hit it a few more times, right, it's going to act that same different way throughout until we're done finishing it.
Okay.
Right?
Yep.
If we use up that water that's available there because we burn it up, we do whatever, we hit that spot extra, yeah, it's going to act different than everything else, right? There's many pieces to it to try and we're not talking long enough about certain things because we're bouncing, but things get brought up. We need to talk about them properly. If you're properly managing, I mean, this is 12.5% 1L behind me in this, and you see those long straight. The reason is calm, hitting it at the right time, having those long consistent runs. Don't be finishing and putting hot spots. Really? Why? What's going on? If it's a hot spot, you should see that as a load, not as a single, what happened right there. Well, most likely it's because someone was trying to take care of a defect and they over finished a spot, right, and kept going on it.
Does happen.
So, yep.
Bobby,
so
you were so I see we have some questions. Mike, I know there's one from the comments. Let's get to that one right now. Let's see what we had in the comments.
What's up? Todd Booth asked, so what is the best way to stop the early water evaporation? You want to get on early? What's the best way to stop the early water evaporation?
Have enough in it that it doesn't evaporate early.
As
the cement matrix is
give me a 7-inch slump. We're back to the 7-inch slump.
I mean, it doesn't have to be a 7-inch slump. It's about the water cement ratio, but that's the easiest thing to associate it with, right? But as the matrix closes, it forces water out to the surface. However, even your 0.45, 0.46 works really good on your slab. The next day you're pouring on 6 inches of AB3 that's laid there for a month and hasn't been touched. It's toast because it's drawing some of that additional water you need out of the bottom. So it's very situational, and that's why there's no just prescriptive answer. Here's the ticket, use it on everything. It just doesn't work that way. Some people have said it that the finishers have been getting away with murder for years. I don't believe that because I've been part of a lot of that. However, the line's a little bit finer now, and being aware, being educated is really important.
Sure.
Yep.
And that's part of it too, is that I know we get a lot of kickback and guys are just saying, well, I don't even want to deal with it. I want to go back to the old stuff. And it's not really the option. So the only option is to find out how to deal with it. And I know a lot of guys, and I don't want to bust balls, but they say we're not supposed to be chemists, but maybe at some point that becomes part of that's part of being a finisher maybe at some point. If you look back in, the Egyptian times, the Masons were magicians, you know what I mean? So maybe we need to go back to that. Maybe we're a little more intelligent than just the old meathead with the, hard hat on. So I don't know. So yeah,
hang out,
Steve,
tune into more of these sessions. You'll learn stuff.
That's it. Steve, go ahead.
Yeah. You guys agree. So the target here where I'm at is 14.5. It's a lot different finishing 14.5 than it is 8. It's a world of difference. 8 to me is normal.
Right.
It's close.
Except for a little bit of delayed set. But 14.5 it's a real challenge. And I mean, we're figuring out how to do it. We're having to have more labor to do what we have to do because we have to work a lot harder when we can't even run on 14.5, we can't even hardly run a pattern because you can't run but so much before it starts ripping it open. So we don't use steel blades anymore. We could using those a long time ago, but we've got it. We're figuring it out. We're getting it figured out, and I'm not a
Okay, so that might be one of the tips
that
right
makes,
there.
that makes sense. That makes sense with your surface durability going down. If you're just running plastics and you're not burning with the steel anymore, that's why you're.
I'm not running plastic.
Softer.
I'm not running. I don't run plastics. I've only run them one
just
time.
Running combos.
I'll run combos. I'll run the medium. And the reason I did that is because the reason I went to that, I really think we can overfinish concrete. We're densifying the surface with these big machines. We're killing the surface, running over it and over it with these heavy 2,000-pound machines. Mm-hmm. So we can. When they came out with polycarboxylate with air, we knew it's a possibility we could get a little more air than 3%. So we went to a combo blade to kind of. We finish it. It's slick. It's smooth, but it's still open a little bit. Just in case.
Right.
But
you need slag, Steve. You need slag in that mix.
You do, and I'm going to speak real quickly to the weight of the machines, okay? Because I am a huge proponent of the BCA and actually doing true abrasion resistance testing, and we've done all that stuff, and we've done it very in depth with Sam and his group. And when you're using light machines, so stick machines. You're going to have about 1,500 of abrasion resistance. Jumping to heavy hydraulic machines and reversible combos and running steels all the way, we have 4 zeros. Okay, you're 2/10,000ths of an inch. Okay, of abrasion resistance. Versus doing it with light machines and being 1,500ths. So huge difference. And the heavier machines and finishing it out heavier, and that's even with the 1L. Okay, it's properly finishing the slab, and that's for high tolerance slabs, doing all this. That's great. That speaks to one function. Go ahead, Don. Sorry.
No, finish your thought.
So that speaks to that function, but then we need to speak also to the paving and to the decorative and for the other things.
Burn finish,
because
not the burn slabs.
True.
Correct, not the burn slabs. But I want those things. Being a trial guy and doing all this stuff for years and years, I've done a lot of studies in that. And it's all about that compression dewatering, just like Steve said. Compression dewatering and mechanical densification requires properly stepping through the pressure increasing on that surface to drive those particles closer together. So, and that's what creates your high abrasion resistant surface.
Can you speak to the Mohs score on those slabs that you tested?
Absolutely. So on these slabs like that, Don, we're running now. If you're running without our stuff, you're running typically about a 3.5 Mohs. Okay, right at the very end. So within 5 to 7 days, you're going to be 5.5 Mohs typically. Okay, when you use the systems that we've created for this day of placement, we're running 5.5 to 6.5 Mohs. So
Emil, did you have something
on day one?
On day one, before saw cutting. Okay. And Sam can give the nod. I mean, that's the facts. So
Emil, did you have something to interject?
So just guys, I think we got a little off subject with some of this stuff here. So I'm getting some text messages from some guys here as we're
let them burn.
We're talking. So we still didn't give anybody an answer as to a solution, a liability, what do we do moving forward to make this work? If I have a $100,000 job to pour next week, how am I supposed to move forward with that in good faith and know that I'm going to give a product that is not going to fail?
Ready. Everybody ready?
Go.
You, as the purchaser, by the rule book, which is ASTM C94, are allowed certain things. And you want to take full advantage of those certain things. That is, you are allowed to have batch weights. You are entitled to batch weights. You're entitled to get a mix design prior to pour, however many days out you want, need, whatever. And as I don't care if you're doing a freaking residential driveway. If you don't know what you're putting down in the concrete, what the hell are you doing? Like, you guys are the front line. And like, I think I texted this in a group earlier, was you're going to a butcher, you own a restaurant, you don't go into the butcher shop and just throw a bag at the butcher and say, hey, go in the bag and give me a bunch of fucking meat. I'm going to cook for my customers out here and serve it to them. You don't do that. You would never do that. Why are people pouring concrete that they don't know what's in it? You're just trusting some random dude. I'll tell you what, I was a ready mix guy for a long time. They're shady. Sorry, ready mix guys. They're shady.
Right from the horse, my friends, right from the horse.
Hey, I was one.
Sure,
so I know
sure.
how it works. But you need to know certain things. What is the blend of that cement? How much limestone do you have in it? What admixtures are they going to put in it? You cannot do your job properly if you don't know what you're being handed when that truck comes. So that mix design will have your water cement ratio. It'll have all this other stuff in there. And when you see it, and that water cement ratio says, because you've been watching this roundtable discussion, and it shows up at a 0.39 on this mix design. Hopefully you guys know, because you've been listening, that's bad.
Well,
like, I'm pouring outside. Yes.
Sam, we need to actually go and actually have another roundtable specifically about those things. But
we should.
The thing is that so your batch ticket says what it was designed as. It'll show you the as delivered, right?
Mm-hmm.
But then you also need to jump in there and do your own math and have a look at that thing. If it says it's got 517 pounds of cement in it and it's only got 125 pounds of water, right? That is not that as delivered of what it's saying. You've got a 0.2 something water cement ratio. It's not, you're not getting what you think you're getting.
Right. And along with that, you request a mix design, and then you request batch weights on every delivery ticket. So you have here's my mix design right here that you guys gave me. Here's the batch ticket that I got. It doesn't match what's up. So, and those batch tickets have valuable information, like that trim water we talked about earlier. And if they're trimming out 5 gallons a yard and you don't put it back in, you're not at this design that they sent you to start with. So these are all like, everybody pouring concrete should be asking for these things. This is,
but there are a lot of guys that just don't know. We may understand it.
Yeah.
Because we're in the thick of things. There are a tremendous amount of people who what you're saying makes absolutely no sense to them. They call their ready mix supplier. They say, I need a 4,000 whatever. We're pouring somebody's driveway, and are trusting that the person on the other end of that phone knows their job and is doing the right thing.
Trust no one ever. Trust no one ever. That should be the rule in ready mix. Trust nobody ever in ready mix.
The thing is we know what's in our concrete, and we know our mix designs, our batch weights, all the admixtures. We look at our mill certs. We're still having problems. So that's not fixing what we're dealing with.
Are you adding more water
on site?
No, in your water content ratio.
Like if your designs that you're getting aren't at those what we had talked about, like trying to get that water cement ratio up, it's you're still going to struggle even though you know all these things.
Right.
We didn't see issues until we started getting 11.5 and 13.5% limestone. 11.5 we started getting dusting, chalking. 13.5 we started getting minor scaling down to the top of sands.
So what you're saying is the cement changed, so your mix changes, and the water cement ratio never changed.
Probably.
So that's one of those things where, as the cement manufacturer made some adjustments in their cement, and the ready mix guy did not make adjustments in his stuff. So if you had your batch tickets and this is why these things are important, is like, hey, I got this mill cert here and I got this new mill cert. This went up. Hey, you guys didn't add any more water. What's up with this? I know it's going to absorb more water. Why didn't you guys correct for it? There's so many.
If the percentage is the
crazy
same
thing. Yeah.
If the percentage is the same and the blane's 50 points different, you're at a 430, you're going to have a slower set than if it comes in at a 490. And if you're, I mean, even seeing it's at 13.5%, so we've made these adjustments. Well, long term, yes, it's going to react the same. But if you're coming in with a 490 blane, it's going to go faster than what you were used to on the previous mill cert. So
I didn't mean to jump in front of Bobby and Mike there. Sorry, fellas.
Oh, no worries.
Go ahead, Bobby.
Ben, what I'm doing, Ben, I'm kind of on the same page with you, Ben, and Emil. Like, so, it's really technical, right? And us concrete finishers, that's hard to follow. Sometimes it just gets in our ears and just like wah 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 wah. And I'm not being smart because that stuff is important knowledge that we need to know. If I got a group of guys out on the job site, and if I asked half those guys to join this, I already know my crew would have already already logged off, just because they wouldn't have been able to follow what's going on here. So what I need to know is how do on a residential job. So or my take is that I got listener, not how, because you guys have answered it. So my take was, so once I strike off, right, immediately upon strike off, I need to be covering that. I need to be maintaining and watching my moisture immediately. I mean, like not like in a little bit, not like when we're at the end of the job. I need to maintain my moisture evaporation right away. Right?
Immediately, yes.
See that what Ben Wise has? This is huge right here.
You see this?
Yes.
Okay. What is your job site evaporation characteristics? Where are you at? Because with the 1L specifically, everything over that 9%, like we're talking about, once you get into that 8.5 and above, you are absolutely 0.2 is no longer the number. 0.05 is your yellow. Caution, Will Robinson, danger. Okay, what are you doing about controlling that early moisture, that evaporation?
Well, that's what I'm asking. And that's what I'm going here with. Like, so this is what we need to be doing, is controlling that right away, right?
Immediately.
Yep. Forever we didn't do that. We just would pour concrete. Let it start setting up, start cutting our joints. If it was windy, or something, or I noticed it, that we would do it. Spray the Confilm or Econ or whatever, one of those evaporation retarders on there.
That's because that's because you had bleed.
Yes.
Yeah. And your bleed disappeared.
And that's what we guys need to know. The guys that are out here pouring this on the daily, so I need to be able to go tell my guys, hey guys, when we cover this up, we get to pour this out. We need to cover this up with a real thin visqueen or something like that, or we need to put this down. Brandon, hey, get the sprayer, start spraying this on immediately.
Yes,
that's what we're looking for. Some answers like that.
That's exactly it. Yep.
That's precisely the answer, Bobby, and that is actually what's going to calm this down. So the rule for curing, okay, for that initial curing, and even as you get further into the where we consider intermediate. So what's behind me right now is actually intermediate curing. So during the finishing, you still have to make sure that either you're fogging, you're doing whatever, you've got to watch your evaporation rate. Okay, your bleed, so your evaporation should never exceed your bleed is the terminology. Right. So your evaporation needs to protect your moisture coming out. If your evaporation exceeds your bleed and your bleed is gone and you've got a crusty surface, but you can still use your heel and kick down and you've got goo underneath there, right? You've lost it already. And so some of these things, Bobby, you have to fall back and go old school and go put float shoes on a walk behind and hit it early and break that surface open very slowly. Right. Don't be getting out there and you got to take some hint from Steve Lloyd and some of these old guys that, back in the old school days, float shoes were our friend, right? Not a pan, float shoes, because you're actually, if you use a pan, you're going to deform the surface so much, or it's going to put so much drag on there that you're going to have issues. You need, break it early with float shoes, and some of these things, there are right ways to do this.
Hey, Ben.
Yes, sir.
One good thing is if you go back to a wood bull float,
Yes, absolutely, Steve.
A wood bull float will leave that open. It will leave that open, and it actually, we use it a lot in cold weather because it makes concrete settle a little faster. So
Absolutely.
use that wood bull float. Now, depending on what you're doing, what these people want, if you're doing like the outside work, but the normal concrete finisher, we got to speak in his terms. And
Yes,
he's
sir.
not going to be out there with the Kestrel. He's not going to be out there.
He should be.
Scientist. He's trying to make a living pouring concrete. So let's go back to old school. Should we go back to wood bull float and try that and keep
Be careful with that
as long as we can? But we as leaders have got to figure this out because it's not going to stop.
Even the wood bull float, though, with the increase in surface area because of the wood bull float, you're actually exposing yourself to a higher evaporation situation.
That's what I was
saying. Correct. You will crust sooner.
It's letting that bleed water come through.
Not necessarily. Until those fines actually impact you, because so one of the things that if you really look at it and you break it down, and I don't want to go down a scientific rabbit hole, but if we're talking about we've got 10% more limestone in that surface, okay, so that means 10% of that surface is actually able to freely give up that moisture even more rapidly, because the limestone, it's not really having the same effect with the moisture, right? It's not having a reactive. And Don and Sam, I'll leave it to you guys a little bit to explain some of those things, because I don't want to get too deep on the science side, but it's not holding the water in the same way.
Sure.
And so that actually has an effect on that surface drying out and the crusting.
Okay.
So if we pulled it open and then sprayed it.
Yep.
That would be good.
Sprayed it with con film. You're fogging it, right?
Fog it or con film it.
Yeah,
it'll get down in that surface and hold that surface more. I'll tell you, a little bit of calcium chloride will help it too. I mean, it really has.
Make calcium great again. Make
I'm
calcium
telling you,
great
it
again.
has. I'm telling you. I mean, we're figuring things out as we go and we're getting through. You know what I'm saying? But
if it's
because it forces the water out sooner, and it also allows you to get on it faster.
It does.
Speed to set.
And that's top hydrated by forcing it out of the mass.
I'm telling you,
the faster it sets, the faster you get on it, the less bleed water it loses.
All right.
That's a whole, like, speeding it up. Speeding it up helps.
Right.
If you can get it.
Ben, what was that?
And not get yourself in trouble speeding it up though either.
You got to have the equipment. You got to be prepared for it. You got to be on your game.
Ben, what was that? What was that meter you had? That moisture.
So this is a Kestrel 5200. This is specific for concrete. Mm-hmm. So you set your concrete temperature in there, and you pull that up there, and it'll tell you what your evaporation rate is. And you can actually set this. It's got a stand. I'll run one or two of them on a job. Sam runs them. We run them on the jobs, and it will log. It'll keep a log for you of what that Bluetooth to your phone keeps a log, and you drop that into the files for that day, and now you've got presentable data.
That's a huge tool for us as contractors to be able, when something does go wrong, if it does go wrong, we always have that data to go back.
Evidence is what that's called, not data in certain situations.
Ben Bass, go ahead.
Guys, look, this has been awesome. What I think we've avoided or just not gotten to, I know there's a lot to cover, but I don't think we've touched on exterior concrete. And I believe that I would say a good half, if not more, doing exterior concrete. So let's dive into that side if you guys don't mind.
Sure.
I've already learned something personally. So when we start pouring concrete, our curing starts then, not when the job is done. As soon as we can either spray cure and seal or water. I didn't know that. So I've already learned something there, right? Well, now we're faced with a new challenge. So say we get the concrete down and we get it floated and we spray evaporation retardant, con film, whatever on there. We're not supposed to work that in, but now we need to tool joint. or perhaps get on knee boards or throw color hardener and broom and stamp. How do we get around holding the moisture in there while still working the surface?
So it's very important that you maintain and do not have periods of wetting and drying. Okay, so if you're going to use a fogger, the steel fogger that are like for orchards, you can use that and fog over the surface and reach a very far over that. You can do that if you're using a confilm or that type of thing. The finishing aids, if you're putting those on correctly and putting them on very, very early, right at placement, it's going to give you that window of holding that moisture in there if it's the correct type. Okay, and then you can disturb that. Okay, as was mentioned earlier, go ahead and tool your joints, do the things, do your color, but then you're going to have to make sure that you're also maintaining that moisture and maintaining that curing, because curing is maintaining moisture and maintaining temperature. Okay, that is what the definition of curing is, and you want to keep that in that safe zone and not have periods of wetting and drying. Periods of wetting and drying, if you're putting something on there, a typical confilm, you'll actually exacerbate the evaporation and it will create more capillaries. Okay, it will create more issues, especially if you're putting it on there and then finishing that in. You're disturbing the near surface water cement ratio. You're washing the cementitious particles off of your near surface microaggregates. You've got to be careful with those things. You're supposed to put it out there and let it lay.
Ben, you've got to have a 5 of water before you do that. I mean, you've got to have a 5. Yep. It's just like shakes back in the day. You had to have a 5 of water. You've got to have water to put that dry. If you're doing
if you're putting shake on.
If you put
we usually pull like half or maybe even all of our mid range out if we got to do that.
Yeah,
yes,
I mean, I'm just telling you, you need that water. It's just like getting shakes in the floor.
Yeah.
Going back up for a minute, it seems to me that one of the biggest things that we can do to help ourselves on these slab on grade installations to maintain the moisture is this, before we even pour, is to dampen down that fill. I mean, I see all too many jobs where the base course is irregular. I'm not talking about the degree of compaction. I'm just talking about the uniformity of the base. Okay. Yep. I see some base that in some spots it's very good, and in other spots there's virgin soil sitting there at the surface. Those two surface differences absorb differently, and they will show up in the top of the slab when you're trying to finish it. So to me, even if you only put down 2 inches of a uniform open graded material and consolidate it, I'm not talking about compacting it, consolidate it as far as it'll go, bring those stones together, and then dampen that course before you start anything. No puddling, just dampening. You're a leg up already, because you're not going to have the bleed water, 10-20% of it finding its way into the soil. It's going to come up. It has to come up, because it won't go down. So that's the first step in curing in my book, is dampen that surface.
And we do that on pavements all the time. We do not use poly under outside pavements. We make sure we dampen that substrate before we put that concrete on it. I mean, it's going to help you.
Sure.
Absolutely.
Emil, did you have something?
So, 2 things then. Don, should we be putting plastic down outside? And then the second thing would be to Ben that all of these finishing aids then have been mismarketed for a long time, where we're talking about putting them down, right after we strike it off before we bull float. Day one and things like that have always been marketed as a finishing aid. It's going to be your savior as the slab is getting away on you, help you put your color hardeners and things in. They were never marketed to any of us as to spray immediately after pouring.
Yep. I agree.
Because Yeah. So
And
Don, talk to the poly if you would.
So the poly to me is the easiest thing. You have it on the truck anyway. Maybe you need a little bit more for a bigger pour, but absolutely put it down. As soon as you strike it off, if you're going to continue to pour and strike, continue to cover it.
He's talking about.
I'm talking about under the slab, Don.
Yeah.
Oh, under the slab. Okay. I'm a proponent of poly under the slab, and I'm not talking about it's got to be as watertight as possible. I don't mind holes in the poly under the slab. Lose a little bit, the excess will find the holes. But for the most part, I have some a petrographic analysis just from this week where there was poly under the slab, not one air hole, there wasn't anything but a smooth finish on the bottom. So all that water went up to the top and it was usable. So I'm a proponent of it. You don't have to worry about having some holes in it, but it'll help a lot. So either that or dampening that surface.
Yeah.
You know, I like to see it soaked the day before, and don't touch it the day of. So it is uniform. It's spread throughout the fill, and you're ready to go.
So like the poly helps the concrete slide too better as it cures down the road. So it gives it a little bit of gives it more of a friction loss. So it will try to crack more in your saw cuts and your tool joints. It helps relieve a little bit of that tension mid cut.
Yeah, exactly. We've all seen the slabs as we were cutting. Get to the last foot of the cut and see the slab rip in front of the saw. That tension is enormous in the surface. It's enormous. And we're talking about moisture preservation. I don't want to get off on the saw cutting, but the moisture preservation starts with dampening that surface.
Yeah.
Don, can you clarify if you're talking interior or exterior for the poly under the slab?
Both.
All.
Every.
Yeah.
It's if you're not going to properly moisture condition, as Don, I'll just put it in true technical terms. Moisture conditioned slab or under slab is absolutely needed. And if you're not going to do that, then put a light poly there. Because that water is just absolutely draining out of your matrix.
The photo behind you looks like bone dry soil to me.
Correct.
You had poly under that?
Of gallons. No, sir.
No?
That had thousands of gallons of water put on it.
Okay.
So that had a couple. That had a couple of water trucks. That's 45,000 square feet right there.
Yeah,
that was proper. Yeah.
Mm-hmm.
Okay, so we've got the subgrade, making sure that's not sealing our water. We've got making sure we're thinking curing right away. Now, what can we do? What about as we're striking off? Now, I've been a part of a panel once before. They said VibraStrike is bad. Where do we go with that?
Excuse me?
I've sat in on a panel once before, and they said we don't want to vibrate our concrete.
So the more water at the surface, the better chance of evaporation, right? That's what we were. I mean, when I was coming up, you pour too wet and it bleeds, you're going to have shrinkage cracks.
Sure.
Well, so the vibration, bringing the water to the top. Obviously, everything we're saying there says no, you want the water at the top. So
you can't carte blanche that question and have it fit every place, every situation.
Sure.
Really.
Sure.
I mean, we're if you take that equation and move it up to Minnesota, where they have the reactive aggregates in the sand, you're going to pop outs like you never saw in your life on a slab. So it depends on what you're using for your aggregates, especially your sand. And what about the jitterbug? Are we bringing the jitterbug back?
Ooh, I should have never went away. There's
I agree.
Things. There's on interior slabs. Okay, let's keep it in its place for where it's meant to be. All right.
Yeah.
But there was a question to the second part to Emil's question, as far as the evaporation retarder versus finishing aid, and the misapplication, or hey, we didn't know this, or have they been misprescribed? Okay, the misprescribed, or the incorrect usage of a finishing aid, okay, to save a slab late in the game. Those are all because a lot of those are chasing things that I'm the one who did all that stuff. Okay, they're chasing something that we put it down immediately at time of placement. All right, let it lay there. Yes, you can bull float that if that's what you're doing, or you can spray it out of the screed and put that's there. It's protecting and maintaining that internal moisture from time of placement. Then as we're going, we put on a little more while we're panning. Yeah, it's there. There is a way to use it like that, Emil. There is a right way to do it. Now, if you use certain of these that are a higher pH, and you apply them late, they are, because they are so close to the pH of the concrete, they have a very quick gelling. Okay, it's kind of got a snotty texture. Yeah, you betcha it does, right? And you better be careful with that, because that snotty is actually hydrogels that are also going to block your bleed. So you got to be careful about that. So there is a right way to prescribe all this stuff, and putting it out there and putting it on early, doing these types of things, it's done for a reason. Okay. So if you put it on late,
I'm sorry.
Go ahead. Go ahead.
So Ben Bass and Emil talking about finishing aids. So you're saying get it on so early. Evaporation retarder? Are you referring to evaporation retarder, or are you referring to the finish aids as well? Because they specifically said they were using finishing aids, and you're saying go ahead and spray the finishing aid on early. But you get away with that; it would be beneficial.
Correct. Correct. That by putting it on early, and that's going to hold that moisture there. Okay. And I can put some pictures out, as we're not sharing screens and doing all the things, we can jump into this, on another one. But when it's done correctly and you put it on early, it's maintaining that early moisture and that early evaporation, right? The moisture is the answer. Sure. And it is what we're having to deal with. And there is a greater sensitivity to these the blended cements. And so much of it has to do, yes, it's got the limestone, okay, but we experience a lot of the same sensitivities to the ternary blends and to the 1S, the 1Ps, the 1T, all of these guys, they're a much finer blend, okay? And when we look at that, we're talking about sometimes a higher than 50% greater surface area. So it's going to steal the water, right? And it's not that it's stealing it, is that it's not available there to bleed because it needs it. It's actually wetting out and it's gaining strength faster. I mean, these are actually in the type 3 range of blends. And so they react a lot faster. Do we forget what type 3 was? What is type 3, guys? Type 3 is high early, right? And so when we break it down and we kind of pause and we go, wait a second. Okay, here's where we're at. This is what's going on. These are things that make sure that you're getting up. If you're going to be, concrete finishers have to evolve, and to the legends that they claim to be, right? Learn enough about the what we're working with so that and Ben Bass, your questions are, it's like learning that the curing starts from the time that it leaves the back of the truck. Oh, I didn't know. Be humble enough to know that and go, shoot, we better start doing something about that. Those are the types of things. And that's where, man, champions evolve we learn something and we move forward, right? Okay, now I know I have to start watching that. Well, I didn't realize that was a big deal before.
Ben, did you have a question?
For sure, yeah. I've always first and foremost admitted that I'm always a student to the game. There's always more to learn.
Absolutely.
We all
Yeah,
are.
so
We all are.
that's yeah,
Yes.
and we talked about this in the chat, but this is such a, I already knew it was a hell of a deep rabbit hole, but holy cow, it goes down there. And I know we should probably stay out of a lot of that stuff, but there's two things I wanted to bring up. Interior and exterior concrete. I typically wouldn't use evap retarder or finishing aid unless it looked like I needed it. Are you saying that it should be applied immediately on every job?
Pretty much. What's your
If
Go
you're
ahead,
in
Sam.
if you're in
What-
Southwest Florida and it's like not a breezy day and it's like 90% humidity and you're dying out there, you're probably okay.
There's enough perspiration to keep the surface wet.
I mean, it depends on where you're working in like ambient conditions. That's one of those.
Correct.
Like we start looking at a big pour the day before. We know we're going to pour. We're going to throw down a couple thousand yards tomorrow on a slab. Hey, what's the weather going to be? Ooh, windy. Ooh, forecasted low humidity. Ooh, let's get all these things ready. And they're there, they're ready to go. And all our, like we said, I have kestrels stuck everywhere in backpack, in my truck, in my desk, and my vest. I got them all over the place. And so do our crews, and they have those, and they know, like, hey, if we get below this 0.15 or close to 0.15, we're going to start throwing the stuff down and be ready. And it's really about, and that's part of it. It's not saying that. Like back in the old days, that concrete was forgiving. It was more forgiving, but those were still things you guys should have been doing. Like our crews, this isn't a new thing for 1L for us. Our guys have kestrels and do all this measurement and look at the day before and have all these things prepared. You just need to do it more now.
Yeah, we're not playing checkers anymore, guys. We're playing chess. You need to learn how to move the pieces.
Like if it's no winds, humidity 70 or above, we may not need to do it, but most of the time we should probably be spraying this stuff right after we strike off.
That's correct.
70% humidity isn't hydrating.
Correct.
Yeah. Okay. Yeah. And then my other part was not to retract to the plastic versus the wet base, but we always pre-dampen our base the day before, and I typically do it the morning of. And we have granite, crush and run is what we typically use. If we put plastic down, I'm just not sure. So I thought the base or gravel underneath was also acts as a filtration system. So if we have visqueen under there, how does that work? Of water getting under there and freezing and kind of getting trapped.
You're not that vapor barrier ain't holding the water. Vapor barrier.
Well, we don't caulk all of our joints, our saw cuts. So, I just don't know about the water.
It's going to go down and out the sides. The path of least resistance is the way the water is going to take, and it's not going to try to get from between the slab and the poly. It's going to try to go out your saw cuts because your saw cuts are going to open up. So they're going to head out that direction. We pour in places where. Man, we should have used a vapor barrier down outside because dry places like the desert eventually rain. And then all the open saw cuts then can go straight down into the not just the subgrade, but the sub base and all the way down into the original soils, and you get hydro compaction. And then you lose your subgrade from underneath your slab and your slab falls in. So, I mean, poly's not a bad thing ever.
Okay.
Yep.
All
and
right,
that drainage that you're looking for in that subgrade isn't necessarily drainage from the slab. It's drainage from the soil, and so the water has room to expand and contract with
Exactly.
Right?
Yeah.
Exactly.
Yep.
And you're poking a bunch of holes in that vapor barrier anyway, for the most part, while you're walking on it. So it'll get, if something gets under there, it'll get out. Don't worry.
Sure.
There's always the number 4 walking stick.
Right.
Is there a fix? Right? Is there a fix for the problems that are already here, that like on our jobs, the ones we're still addressing from the year last year, or that came over. We had a tough winter up here in Delaware, so it seemed like we had a lot more callbacks this year. Is there a fix without tearing it out?
That's already come apart on you?
Yeah, the top's flaking.
I mean, there's all kinds of armor hard, all kinds of stuff. We would. I'm glad I don't say who I work for. We repair a lot of crap. You go through and we fix a lot of stuff. Armor Hard is great. There's a couple other ones. You can go back through, blast the top off, get all the loose stuff off, maybe shot blast, water blast, whatever, and then just put down a thin coat.
For me, in that case, like to do all that, like, and I'm talking about like on my residential side of things. For me to do all that, it's easier and cheaper for me to tear it out and put it back in, just because it's we're efficient that way. But I'm at call, I'm on the hook, if that makes any sense.
Right.
And that's the hardest part is like, man, this product that I didn't, know this about is, I guess it's like then I guess I'm taking the responsibility. So
the other people think people should be doing, here's the very most important thing about this whole operation. 28 days later, after that concrete's cured, come back and put a penetrating siloxane base sealer in it.
We have gone to that.
Keep the water out to start with, and you won't have a problem down the road.
Bobby?
Yeah, go ahead.
I would say that you're on the hook, and ACA is laughing all the way to the bank.
We weren't supposed to say letters.
That is so true.
My God.
That is so true.
He said the letters. Here we go.
The truth will set you free. I'm not a well-liked person anyway.
You call it the PCA because they're gone, so you could, and everybody knows what happened. So you say PCA and it's okay.
It's public knowledge. Just look at the financials. That's all you got to do.
Okay, so let's. I want to kind of touch on the decorative side a little bit more in terms of throw and color. I know that I've talked to Don in the past, and he says you want to make sure you got a mix that's going to bleed if you could throw in color. Now, what about using the finishing aids to hydrate the cement and the color for that?
So you need to be applying that early. Okay, so right at placement and
the color
put down
or the finishing.
No, the finishing aid.
Okay.
The aid. Okay. Mm-hmm. So you put that down because that will actually, if they're properly engineered, there's a pozzolanic reaction that goes on that's going to be a nano blanket that's allowing moisture. It's semi-permeable. It's allowing moisture to still come out. It's allowing the bleed to still happen, but it's maintaining that internal moisture. The other thing is that when you're doing that, just like Steve Lloyd brought up earlier and Ben Bass was talking, right? We want to pull out half or all of that mid-range. We want all of our water, okay? Desperately needed if you're going to apply a shake on top. So if it's a shake on hardener or if you're throwing color, you need the water there.
Okay.
Because when you put that on now, you're actually going to starve your near surface if you have not thought ahead and change that mix design. If you're just taking that out of the box mix design and you're throwing that out there and they actually delivered you a 3/8, you're screwed. You're done.
Mm-hmm.
Right? It's not a matter of if, it's when you're going to have those little pockets of delamination, right? And so we need to actually look at that mix design and make sure that you're getting your water. There shouldn't be much trim water, if any trim water at all, if you're throwing color.
Okay.
And another thing is they don't recommend putting machines on, but if I would definitely use float shoes with that.
Walk behind with float shoes.
Float shoes to get that color in there,
Absolutely.
I mean,
Ben, did you need clarification on that?
Yeah, I did. I just wanted to bring up a prior project. So we worked on this awesome house, the back of the house, 60 something yards, pool deck, 3 patios, 20 something steps, same mix design, pulled out the mid range, all shake on color hardener, same brand, same color. It's in the middle of the summer, did all these, great success. 1 year later, we did the driveway, 8,000 square feet of stamped concrete, same mix design, same color hardener, same brand, same everything. The whole driveway is flaking and scaling up, but the back of the house is in perfect, brand new looking condition, even on the edges of the walkways where no one is walking. Here's the crazy thing is I can take a 4,000 PSI pressure washer super close. I have a video of this. Nothing around those scaled penny size, quarter size spots will come off. You would think something connected to that would come off. none will come off. So I just started assuming that, okay, well, now type 1L has made its way into these shake on hardeners. I don't know what to think because everything else was the same.
You may not be that far off. I don't know that. I can't speak to that precisely. But if you look at anything at Home Depot or anywhere else, they don't say 1-2 on the bag anymore.
Say or. Yeah.
They right. It's everything is pretty much a 595 now. And so I can't speak to what you had as your shake, but your colors when you're getting those, everything else was the same. Your cement, like you were
same
the
mix
same 1L?
design, same exact everything. It was just 1 year later. Now our cement from our ready mix changed.
Absolutely. And
yes.
So the thing that I would be concerned about there is what was the percentage of limestone? What was the blade?
13.5.
Yeah. And so did you adjust your water for that? Where were you at for your mix design for your water?
That was something, Ben, that I just wasn't aware of with adding more water, because I always heard the contradicting, it needs less, it needs more. So I'm like, what the hell do I do?
Yep. Yeah. Well, Sam and I will tell you every time I give it a drink, right?
Mm-hmm.
It needs water.
It's so crazy to hear that, what we've always heard. It seems so, but I guess and also the idea of hearing, we don't want the highest PSI on a brake. That's always been ingrained. Oh, that brake has got, it's, 7-day brake, blah, 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 whatever the PSI.
Well,
and it's
let's fall back
making
to
strength at 7 days. I don't care. I
Yeah.
wanted it at 28. Give me some water.
That's a whole new school of thought for me. So this is huge.
And structurally, do you really need 4,000 PSI on a patio?
Sure. Right.
What kind of load you're going to put on that patio?
Yep. Emil, did you have something?
And the higher the PSI goes, the lower the durability goes. That's a big problem.
More strength hurts the finisher.
Yeah.
Valid.
Yes.
Emil, go ahead. Did you have something?
More cement.
I'm
faster
just
set.
thinking about.
That's because you're trying to overcome the problem. Right?
I'm just thinking about what a cool meme we're going to be able to make of Ben Wise saying, "Give it a drink."
Yeah.
Well,
That's good.
When was the last time you guys drug a hose over the slab to pull the bleed water off?
It's been a bit.
Yeah.
I can answer that, but it's not fair because we run volumetric, so we see.
So let's
Okay, lucky
Zach,
you.
talk about that a little bit. The volumetric. You have a big push for that. Talk about that a little bit. How is that beneficial?
I do, and I'm going to start by saying that when we purchased those, I was hoping we were buying a new boom screed. And instead we came home with 2 volumetric trucks, so I wasn't really for it. But the more I've been around it, and the more I've seen the process and the way it works, I believe in it. The way that the aggregates and the cement accept and reject the water right there in place, I think it really helps, especially with 1L and high evaporation situations like we face in Kansas quite a bit. So it's just a matter of learning how to finish it a little bit different and place it a little bit different, and having the flexibility to adjust that water cement ratio at our own will. It's really done great things for us. I mentioned in the group chat about canceling a small slab, a 5,000 square foot slab, because of an evaporation rate issue that day, and proceeding with the 12,000 that we poured with volumetric. Mm-hmm. And we just backed our water reducer off quite a bit, threw more real water at it, poured a little wetter than we normally would, and we had a lot of success with it. So nice. I'm not sitting here as somebody who's trying to pitch or sell anything. I'm sitting here as a guy who finishes concrete at least 3 days a week, and I believe in what everybody is saying about water.
Sure.
Working with your plants. If you get the opportunity to run volumetric, try it. A lot of people have had issues in the past because of the bleed water, but what has once been a problem is now a solution. So try it.
And you have a big leg up because you don't have a transport time.
Absolutely. Yeah. And that I believe that the matrix closing in place is really important to development of strength and things like that as well. Okay. Instead of being agitated over the drive time and things like that. So there's a lot of good things about it. And I think if you have a chance to use it, give it a shot. I know Sam disagrees a little bit. It's not his favorite thing, but
you got a a whole fleet of volumetric.
He's got a
rods.
fleet of them. What are you talking about?
Just
That's how we do all the
doesn't mean
bridge
he loves
decks.
them.
I don't like them. I don't like them. That's for bridge decks and stuff. I don't like that.
So from a decorative standpoint, the coloring. Well, before we get to coloring. So let's talk about releases, stamp releases. You got the bubble gum and you got the powder. Is one better than the other?
Yep. Powder's better.
Okay.
Powder's better.
Obviously,
and powder's better because it's going to hold moisture.
Okay. I know from a stamping standpoint, you can get a way better impression and a way more clean look with powder, and we kind of push it for that. But it is also better for the curing then, huh?
Correct. So when we're talking, and this is studies that we've been doing, and Rocky, I'm gonna be leaning on you hard.
Let's go.
As Sheriff 310. We've been working on this 308 310 joint committee about curing for decorative concrete, right? So curing for decorative concrete has always been misapplied applications of, you've got to use a 309. Well, I'm telling you what, you better not use a 309 on you've got something that you're doing a stamped, or if you're doing so let's say we're doing exposed aggregate. Really? You're going to put a 309 on that? Buddy, right? So these are types of things that, we've got to actually, figure out those finishes, and then let's work together on what's the best way to cure them. Well, if you've got a bubble gum release, and all of our old type 1-2s, that worked great. Okay, it served a purpose. It was solid. It's still a good way, but there's good, better, best. Okay, and a hydrophobic powdered release is going to hold moisture, whereas a bubble gum won't.
Okay.
Period. So, but and so after we did these tests already, and when we did that, so after we stamped, we threw out even more powdered release, extra to act as a blanket to hold it. Now, is it going to do much? Listen, we're just talking. It's Tiny Tim saying, more, please. Okay. he wants moisture. That's what that concrete wants, moisture. Okay. And so we need every bit that we can. And so if we're doing something, and, as Don brought up earlier, putting the plastic over the top of it, that's a solid, guys. Right.
And if you're using the powdered release, you could do that. You could put the plastic on there.
Absolutely.
Yep. Okay.
And not have tiger styrofoam, because you've got something in between.
Sure.
Right.
Yep. That makes good sense. Ben, go ahead. Did you have a question?
Well, Ben just brought up exposed DAC. So that's one of the things I've been pushing. We have a potential 24,000 square foot residential driveway, and they want it stamped. And I am trying like hell to push them into, exposed ag or sand finish.
Exposed.
Yeah. So I'm bringing that up because it makes a lot of sense. Not to go back to the driveway we did, but we sandblasted a big stencil in the middle, and that was the only thing that was not affected. And we just went right down into the top of the sand. So my question to you guys, exposed ag, it makes a lot of sense. We're getting rid of the weak surface if there's going to be one, but is sand finish a good option as well? Is it down far enough?
Yes. But you're going to put your retardant on there and then put plastic over the top of it.
Yep. But as soon as that's washed off and good, which I love the retardant because it's holding the moisture in, right, to y'all's point.
Yeah, you just need a couple. You need to get that early strength. That early strength and is where you get your durability at, right? That's where you have issues. If that dries out in little spots, those are your bleed points. That's where it's gonna flake. That's where you're gonna have issues.
Okay.
Thank you.
Yeah. So now so I guess we get into a coloring standpoint a little bit. Are there going to be different styles of coloring that are going to be better to last longer? Maybe stick with acid stains, water based, maybe good, maybe bad, or does it really matter?
Acid's going to act different.
Okay.
With the 1L.
Sure.
Okay.
Yeah.
Your reactable surface, your differential there, but an acid is a permanent.
Sure.
Right. That is you're going to see. So if we're talking about let's do shake-ons, let's do acids, let's do things that are actually permanent, not something that's not going to hold up in UV.
Mm-hmm.
Right. Are there things that can be done there? Yeah. Right. But love me some shake or integral,
Sure.
and then hopefully that's giving you a little bit better cementitious as well.
Yeah. Yep.
But pull out if you're putting in. Don't do like Steve was mentioning earlier about how they just constantly just add more, right? Don't just, oh well, we're going to put this in there. Well, what are you doing about your water, right? Don't think about your mix design from a 30,000 foot view. Look down. You're playing chess with the 1L. You're not playing checkers anymore.
Sure.
And so be thinking about your mix design. Be thinking about your finishing techniques and the ownership of your project. You're not just doing checkers anymore here, guys.
Yep. Okay, so then I guess into the sealing standpoint, obviously we want to wait our 28-day cure. What do we want to look for sealers on this? Are we, when I first started stamping it, everybody wanted that nice shiny, 30% solids and looking good, but that's probably not what we want right now with this 1L, right?
You can, but put real sealer on it first and seal it. That's a glossy exposition style prettiness. That's not protecting the concrete. Okay. You can go on and put a penetrating siloxane, a high solid siloxane on it first, and come back the next day, same day even, probably same day even if you go early and come back late. But then you can put your glossy stuff on.
Yeah.
But you protected your concrete first.
So that siloxane is key to that initial.
Yeah.
But one step before that is the use of a good cleaner to make sure that you get the powder off. I've seen many projects here in Chicago where we lost the surface in little specks here and there, and it turned out to be little buildup of powder left in the surface that didn't come off with just a pressure wash. It needs a detergent. It needs a cleaner specific to take that off, to make sure that it's all off.
We recommend, anytime you do the antique release, that you use a floor scrubber to buff it afterwards, so you get all that off. So that we always say that's one thing you want to have on the truck no matter what. Ben, did you have something?
I did, yeah. To go back to stamped concrete, so Emil and I have talked about this, and recently the last few jobs we've done, we've actually done this. Prior to that, we haven't. So do you guys recommend stamped concrete? It's done, it's cut, it's cleaned. Would you acid etch at that point? And if so, it makes sense to me to kind of expose some of the sands. But if so, what type of acid? Muriatic acid, hydrochloric acid, there's all these different acids. And then what do we neutralize with if you think that's helpful for that sealer to bond and to get rid of some of that maybe brittle paste?
So if you're going to use an acid, I would actually go with a synthetic acid, and go with. There are several that are out there. The slurry guys have them. Okay, so right within your normal chain of custody of the guys that you're working with, they've got the different types of acids. When you're using those synthetic acids, they'll have a reaction and they're done. Okay, these are the same acids that are used in your water treatment facilities. Okay, and so they're not something that need to be, I've got to neutralize it, throw down baking soda and wash that thing and make sure, because it's going to keep going. Once it does its thing, they're gonna eat thing and then they're done. They're not going to keep going and going and going like a muriatic or a hydrochloric will, Ben. Okay, so there's just the same type of, we use these for cleaning equipment. We use them for doing all of these types of things. So, but if you are using, absolutely have to neutralize that. So,
is it necessary? Do you think that we should be doing that?
it will expose it will expose and take care of things so that you can take care of them while you're doing it there.
What do you mean by that?
Well, if you're going to have defects, it will show a defect. It will show it early, where you'll know it won't be something that you're called back next year. Okay, so if you have something that's going on that you're going to call back your ready mix guy, hey, what the heck is going on here? If you've got dirty aggregate, if you're having flaking or some weird funky stuff on your near surface aggregates, it will show that.
For me personally, that's best case scenario. I'd rather be on the job and handle it then than a year go by and have to go back and try to fix the shit then.
Yeah, that money's already spent.
Yeah. You got it, Bobby.
Emil, go ahead.
So our commonplace for the past 10 plus years has been that we will use liquid release. We will come back. We will do our sock cutting, cut our designs, rinse that thing off with a pressure washer, hit it with a light acid solution. We usually use Proseco SureClean. Damp surface. We'll hit it with acid, probably like 8-to-1. Run the force scrubber over it. Make sure that we're getting any residue off from our bubble gum, anything that we might have left behind from saw cutting, anything like that we're getting off. We will neutralize it. Run the force scrubber on it a second time. Rinse. Then we will stain, antique, and seal. Our success rate on sealing stuff and having no issues is 95% or better.
Now, Emil, you brought something up there really so if you're going to do any acid staining or you're going to do anything like that, you don't want to use acid on it.
Correct.
Right?
We are not using acid.
That will actually affect your ability to stain that surface because you're going to take away your reactive product. So all of those things are all, peekaboo, what happened here, right? You just wiped out everything that was reactive if you used acid on it.
Okay, that just wipes out something that somebody had taught, obviously wrong, that you want to acid etch it before you acid stain it, and that is not right.
I think you'll still get some reaction there, Rocky, but it just won't be as vibrant and intense.
It won't pop. It won't pop.
That makes sense. It makes total sense. All right.
I am a big proponent of water-based stains on our decorative if used in moderation over a proper substrate. If we have cleaned right, done our job, exposed that little bit of sand, it could bite in.
Yeah.
We have gotten exceptional longevity out of it.
Yeah. And it's then what Emil's discussing right there is properly, it's not only properly conditioned beforehand, but also then properly protected. Okay. Correct. And Emil does a great job of actually proper chemistries that he's using for his protection. Some of the same stuff that Sam was talking about earlier.
Wow, I feel like I've been just completely schooled. I think the only thing that I'm still, not still, but I guess the only thing that we haven't touched on is, this one might be good for Don. So how do we deal with the issues that we're the financial? Who does this come back on? How do we deal with that? Some tips and tricks that we might be able to do when we're seeing these court cases.
Well, that's a real broad answer. It depends on the situation, of course.
Sure.
One thing that we should all do is to take a look at the exculpatory language that shows up on every shipper ticket at the bottom, and see exactly what they're saying about their liability when they drop off that load of stuff, because it all starts there. Secondly, having the Kestrel log is admissible, and I've seen that used very, very well in court and mediations both. It is, especially with producers that are, let's face it, their pockets are deeper than ours. Some of the big guys have attorneys on staff that deal with nothing but this issue. So it really doesn't cost them any more to deal with your issue. The guys are there being paid anyway. So, it all boils down to whose pockets are deeper and how much you want to spend on this thing going forward. Because just to get in front of the judge is going to cost you 10 grand between an attorney and an expert to get you there. And then, to go through all the depositions and all the rest, you can probably double that. So, it becomes a trade-off of, okay, can I pull a $3,000 driveway out and do it cheaper that way, or do I want to fight my battle with the law or justice system?
True.
It's a delicate balance. It's nothing but the consultants and the attorneys are making the money when you go there. But from a legal standpoint, like the state of Pennsylvania has some language in their merchandising laws about reliance estoppel, which is basically, as a concrete contractor, you're relying on the producer to give you a product that will work the way you want it to work on your site.
Correct.
The problem is they will find every loophole that they can find, even if they're wrong, and point the finger back at you. But if you look through the assurance law in Pennsylvania, and that's the assurance estoppel, you were assured by this ready-mix company that you were going to get a material that you could use. I don't know if you're hearing me anymore.
Yeah.
Yes, we are.
Okay, my screen just went dead for a low battery. If you look through that, you'll see there's about 4 areas that really apply to the situations that we're going through if we have to take this thing all the way to court. The problem is that the judges don't understand construction. They definitely don't understand concrete and chemistry. The lawyers don't understand the chemistry at all, or construction, and it leaves it expert against expert. And it's a two-way street. You're just, if you've got a better case and better background and you're able to explain things better, you got a better chance of winning. So it's really a delicate balance. I try to keep everybody out of the justice system because it really doesn't have a good point of return. You win some, you lose a lot.
And your best chance is your documentation. That goes back to having that mix design that got tickets and Ben's 5200 Kestrel, the Kestrel 5200 there that logs and tracks, and it's a PDF version and the whole thing. Like, it's basically a big game of CYA again, but
it's one after another. It's layers of CYA all the way up.
Mm-hmm.
Every piece of documentation you have, and that is requesting those batch tickets, because if you have a problem and go back to that ready mix company like a month later, say, hey, I need those batch weights. Oh, baby, you may eventually get them, but chances are it's going to be tough. So, but that's...
Yep. Emil, did you have something?
Will probably be able to speak on this pretty good.
Yeah, guys, how do we change? So some of you on the panel know the background here, some of you don't. So we have a problem up here in Pennsylvania, in my area, where we had a supplier with bad aggregates. All right, so I personally have about $250,000 in contract work that is failing on the surface due to bad aggregates. We had a 40-year business relationship with the ready mix plant. They cannot walk out any one of their front doors or their office without walking on concrete that I poured. When we asked them to step up and accept some of the responsibility to help us with this, they pretty much threw me the middle finger and said, "You're on your own." So how do we change this? How do we get to a point where there are laws to back up the contractors, to back up the little guys, so that they don't have these things? There has to be something that can be done that can help people not go out of business.
There are laws in place.
But Don, it's like a cement mixer. It goes around in a big circle with the lawyers and engineers, and they just play a game back and forth until they bankrupt the contractor.
Aggregate's one thing because it's super easy to prove it's the aggregate, and it's super easy to prove it's the aggregate. But then the ready mix guy at that point, he bought it from the quarry guy, so that's where that bounce comes back and forth from. He gonna blame it on the quarry, and so then quarry, you got to deal with quarry. But
we went through this. We went through the quarry. We asked them. The quarry was decertified. We asked them for their reason for decertification. We have gone after the state of Pennsylvania under right to know, asking for the quarry reports. They will not supply them to us. We have asked on separate occasions to supply them to us. The quarry people won't supply them to us. The concrete company will not give us a single amount of documentation.
And hence why that mixed design for your thing, that's super important. And that's part of that legal backup thing to go backwards, because when we have issues all the time. This is a normal daily thing for us. And the first thing we go back through and look at is the mix design. And we have a very stringent process of what is correct. We want mill certs for everything. We have C33 data that's within a year, try to do no more less than 6 months from the quarry. So we know what we're getting before we get it.
In Pennsylvania, quarries don't have to be certified every 2 years, which is complete bullshit. So,
but we require 1 year, and we do a lot of work in Pennsylvania. And I get fresh mill certs. I have certs from all kinds of Pennsylvania quarries that are every 6 months.
So maybe
they want to sell rock
and pull one for me.
So Don, so a question. So Don, I got a question, Don. So
yes,
you've done a lot of. I've been to court a couple of times as an expert witness, and it seems to me that ACI pretty much rules. I mean, if you go by if you don't go by the guidelines of ACI, then you're in fault. And ACI says in 302 in numerous places that the Portland cement content and the content of other cementitious products, if used, should be sufficient to permit factory satisfactory finishability under field conditions. And it says it 3 or 4 times in here. The concrete should not experience excessive retardation, differential set time, which we're getting a lot of because of the chemicals. It says it if you go to mixture concrete materials and mixture proportions, it really lays it out there. It's not our fault that we were given what we got to work with, and it's got to be a workable product. It's got to be a finishable product. I mean, how are we supposed to do our jobs if we don't have and like I said, it states in an ACI. So
yes, I follow you, and maybe this is something that we should do another cast on, or you and I should talk.
Yeah, I'd love to, Don.
Okay, well, let's just hook up on, and we'll talk about that.
Yeah.
But I hear you, and the ACI is the law of the land in the courts. There's no two ways about it. For the work that most people here do, and ACI is at conflict with the actual terms of the laws in the states of Pennsylvania.
Yeah.
Because that's what I'm talking about when I'm talking about reliance estoppel.
Yeah.
Okay, and there's an enrichment estoppel too, that you paid for this product thinking that it would do what they told you it would do, or from their designs that it would perform the way it was supposed to, and it didn't. And as long as you can stand up and say, here's my records, here's what I did, here's my Kestrel log,
Yeah.
here's everything about that project. You tell me what I did wrong because I didn't do anything wrong. And I lost the slab as a result of whatever it was. That sticks. We should talk about that.
We need to, because it's a lot of evidence out here that would protect these guys, because we shouldn't be getting hammered for an inferior product.
Yes.
Well, I agree with you.
Yep.
So when Don is bringing that up, that type of thing right there is the part of the playing chess versus playing checkers. You need to have your daily logs of exactly what went on, and it needs to be your business practice to do what the big boys do. There's a reason that they do what they do. All right. They have that daily log of what went on the project. They have the daily Kestrels. We have all of these things that we put together. We put together, your end of day reports, and your lead man is sitting there putting all of that stuff in. You know what you've got. Plus, you've got all of your batch tickets. You've got your batch weights. You've got everything. And when you start having a problem, you've got all of that information already. You're not going for it, because just like Sam said, when you finally realize that you're having a problem, if you go if you're having it with certain of these guys, that is immediately when they quit communicating with you, and you're not getting anything more from them.
That's right.
It's done. It's cut off,
right.
and they won't answer your emails. They won't answer your phone calls, and you're not getting anything. And if you did not have that, you're done.
So being one of the first things I do is I ask the ready mix supplier, does he have 1-2 cement? And he says, no, I got 1L. Well, I immediately break out a disclaimer, and I say, all of these things are possible. I'll tell the owner, if you get to the owner doesn't really want this stuff. The owner wants good concrete. A buddy of mine that did the same thing, the owner says, we're not pouring the type 1L. They went to the 1-2 if they wanted to pour, and they're pouring with the 1-2. But what I say is these problems could happen. I'm not saying they're going to happen, but it's a possibility they could by using this type 1L cement. These are the problems that could happen.
The poor practices, all those things could have happened in the past too. It's just that cement covered it up.
Yeah,
there's a lot of that.
It's like we're using 1L's like performance-based mixes. Even the sands could be mediocre in 1-2, and we get by with it. Now everything's got to be perfect for everything to work.
Ben Bass, did you have something?
Yeah, this is a lot to swallow. It's like trying to drink out of a fire hydrant. And I think I'd probably speak for a lot of concrete finishers out there. What Ben just mentioned, I don't know if this is something you or Sam or any of you guys, Don, would be willing to do, but is there any information or any way that us concrete contractors could get stuff like the, I'm sorry, was it the Kestrel or?
Yep.
Yeah. So basically what I'm asking for, is there any way that we could get a list of things that us as concrete contractors should be using and documenting to protect ourselves if something happens and we got to go to court?
Absolutely.
So Mike, we'll put together, I think we need to put together CUIs. Let's do our thing that we've been doing recently with these handouts, right? And we'll put together a list and some best practice, and Sam and I can with Don can work through some of those things for sure.
I can tell you this, that the better the documentation is from the job site, the better chance you have of prevailing in court. Because I'm able to rebuild the job in reverse from your records. Okay, and that's exactly what I do. I look at the end result, and then I move back towards the beginning of the job and look at your records and see how they come together. And you can actually rebuild the case and do a complete study that way, and you can demonstrate what happened on the job or what happened with the mix. And sometimes you can interrupt your idea of going to court because suddenly something happened with the process and not the mix. So,
Right. So one of the things too, Don, that Ben was talking about is ripping it out and replacing it. Well, you're just going to replace it with the same stuff.
Exactly. I agree.
The same stuff, but also with more knowledge.
That's assuming the issue was the cement, the 1L. That's assuming that's a total at fault.
That's why we do. We have pre-pour inspections, during pour inspections, post-pour inspection checklists, and the first thing is QC. Hey, there's a problem. We go back to that first. Look at that. I'm going to go look at your pre-pour. Did you put the steel where you're supposed to? Was this checked? Did you check this? We gave you checklists are you just random checking yay or nay? What kind of pictures are in that? It's very important. Like, pictures are worth thousands of words. I went out to a job over in Indiana a couple of weeks ago, and God, the drains look like complete crap. Like, what happened? Like, man, that looks weird. But then I went back to the QC on site, and he had pictures of how we poured them and left them. Plumbers came back the next day and ravaged them because they didn't like the slope or didn't like something about them. And then they took, I don't know what the hell they did to them, but they demolished them things. But we put them in right. It wasn't our fault. So, but we have that documentation there, and that's why it's very important to document everything.
And for the smaller contractor doing residential patios, driveways, everybody has a cell phone. Get a stand for it, put it up there, and record it. And it's invaluable information all the way around.
Everybody making YouTube videos anyway about pouring crazy concrete. Might as well just start recording them for evidence.
But you know, and I'll go back to when I started. I probably abused concrete more than anybody. I poured 8, 10, 12-inch slumps, kicked it around, moved it around. But you know what? I go back to those places and they're still there.
Well, that might not be such a bad thing we're hearing in today's cement. So.
Yeah. Exactly.
Totally different cement.
Yeah. So we're kind of getting long here on time a little bit, but so for the contractors, are your questions answered? Do you guys feel? Oh, Ben's got a question. He's got his hand up. What's up, Ben?
Yeah, I just wanted to add to the list. I really appreciate you guys doing that. I think it would help a lot of people with just having a list of things we should document. Just to add to that, do you think it's not unrealistic, or it's not realistic to go to a residential driveway or a decorative project and core out these samples and then send them off for a petrographic test? Should we be doing like 6-inch PVC, 6 inches tall, just putting mud in there, and as we hit the surface of whatever we're finishing, do that every time on that? Then it goes back to, like you guys just brought up, having to record all this stuff. And yes, we're recording, but I'll be honest, guys, I mean, sometimes, if you got 4 or 5 days of pouring, that is a lot of footage to have. And it's I mean, you're not going to set your phone up and be recording without running out.
Yeah, you don't need to be taking video footage. Okay, I understand what Don's saying there. The big thing
we don't want to see Byron's butt crack anyway when he's bending over finishing something.
Take a picture. Take a picture.
Take pictures. What did your sub base look like? Go ahead, Steve. Sorry.
Take a picture of when you waited 45 minutes for the last load to get there.
Absolutely. And that's the type of things that it's going through. What did your sub base look like? Pictures of exactly when you started, Ben. And here I'm at 40 yards here, and we had to wait now 45 minutes before the next truck came. And then we had service for 100 yards, but then we waited 60 minutes. And then show those same, because concrete is going to finish in the same time that it was placed, right? And so now you show that where you've got this nasty cold joint that you were fighting. Be taking those pictures as you're going through that, and have logs where your guys are, hey, everyone, it can't just be on one guy. I need everybody's pictures. You need to have a way that you can get those all in there. And then you've got to have your lead guys have to be actually
leaders.
what was your daily
One one other thing, Ben, one other thing is, what this load came in at a 2-inch lump. This load came in at an 8-inch lump. I mean, that's a big
pictures
deal
of it.
too.
Just documentation, some
Well,
sort of
You
documentation.
got to be consistent. They've got to be held accountable to bring you consistent concrete. I mean, somebody else has got to be accountable besides the man out here trying to make a living doing what he does good.
But you've got to be
Absolutely.
consistent with your note taking. You've got to be consistent so you've actually got data. You've got to prove that you're the professional in this. Okay. And that is actually we've played too fast and loose with, and you're a businessman. Okay. Act like it. Right. Your tax guy's not going to accept your this was for that. And where's your receipt? And did you not note that? Do you not know what this all is? And so this is really that receipts and knowledge, so that later on when you have to bring in a Don or a Steve or someone else, that you've got all that you can build that job backwards. You need to build that job backwards every night at the end of your logs and do your things, all the things that went on, and put that in the job file.
And what about the cylinders? Like, should we, instead of trying to get, if we ever needed a petrography test, should we go ahead on every job and just fill one of those up and label it?
No, the cylinder's not.
No.
The cylinder's not
No.
a true sample of what you got on the ground.
You need a core. You need a core.
You got to have a core.
You have to have a core or a piece. You can go out and whack the corner off with a hammer just as good, as long as it came from that actual placement.
You want to be selective, though. You want to have the area of problem, and you want to have an area where there's no problem.
Thank you, Don.
Got it.
Perfect.
Thank you.
Good.
Yep.
Okay, contractors. Emil, you feel a little bit better after this? I mean, you feel like you got some tools?
Probably scared everybody.
At least some tools. I mean, I know we didn't nail any solid answers, but we got some tricks. I think that we can tackle this. I mean, and just the idea that we have to kind of change our perception a little bit from what we've been told in the past. So just those things right there are huge in itself.
So we got to start. That's for sure, man. We definitely got to start. This is what we needed to get, something, and it can only, probably go better from here.
Yeah.
And Emil, I got some stuff that could help you. I really do. I mean,
cool. So let's just do a real quick recap. All right. So we know that it starts from the beginning, right? As soon as when it's an infant, when it's that baby, that's where it all starts. So we know we got to do that. Mixes, we could add some things. Oh yeah, go ahead. We'll back up to mixes.
Let's back up all the way to what's back over here on the, to the other side here. Let's back up to our sub base. Mm-hmm. All right. What Don brought up earlier. Okay, let's go all the way from the beginning. Did you prep it correctly? Is it even? Do we have that absolute even field that's moisture conditioned properly? Mm-hmm. Right. Yep. So let's start there. Okay. Then we step into and it even goes even before then, pre-pour. Have we got our pre-construction? Have we went over this mix design, and are we confident? And is this thing exactly what it needs to be? Mm-hmm. Right.
So in that, just some quick additions, mix design. We heard that slag can help. Add that into your mix, right? Obviously, the higher water is something we want to be looking for. Trying to take out some of the mid-range, that kind of thing.
Yep. Yeah. It's not just higher water, but it's proper use.
Proper use. So
it's let's look at that and make sure that they're not giving us a supposed, I gave you a 5.0, not as delivered. You didn't. I looked at that and I got a 3.8. Mm-hmm. I ran my numbers and give me a break, guy. You held 70 gallons. Yeah. Right. Give me my water.
Sure. Yeah, Ben Bass.
Just real quick, sorry, I don't mean to interrupt. I know we're trying to recap, but at the same time, we don't have access to slag. We have fly ash. What do you recommend for a lot of people across the country that don't have slag?
It's not as good, but it's still better. It's better than the straight.
Better than straight cement.
Straight cement. It's just still. It always has been. So I know I get a bunch of old finishers pissed off at me now, but SCMs have always been better than straight cement.
But not class F.
I will
Not
disagree
yes.
with you. I'll
It
disagree
depends
with
on
you.
what it depends on what you're trying to accomplish. Like Class F has great ASR resistance
Yeah.
capability. Like if your concrete's falling apart from ASR resistance years down the road, Class F's going to help that. Everything has
Yes.
and there's a plus and minus to everything, but the minuses to an SCM are usually just set time, and that's what pissed everybody off because they had stood out there too long waiting to go home and grab a beer. It in the long term, all SCMs are going to be better. Fly ash isn't as good as slag, but it does something. It doesn't absorb as much
properly
water.
prescribed.
Right.
Yep.
It doesn't absorb. It helps with your water to cement ratio with more. It gives you more water to the
More
cement
available water
because
to the cement.
you get to count it as a cementitious material, but its absorption is almost non-existent. It has a little, but not a whole lot. So most of that water that you're getting from your is going over here where you need it. It's counting for somewhere else down the line. So anything you can do besides straight cement is always going to be better.
Okay, so there we got mixed design now. Now the placing and finishing, we got a curing right away. That's our main thing. How do we get it down? How do we start the curing? Thinking about curing.
Correct.
Let's see. We get into the finishing
And
principles.
curing at the end.
Yeah. Obviously the curing at the end, so that's huge. Stamp,
all of it.
A powdered release is good. We've learned that.
And it is, and I saw a couple. So I haven't been able to follow along on the all the comments.
Sure,
but
and we'll go
that,
back through and
Rocky,
answer a lot of these. Yeah.
In that, Rocky, I saw a lot of. We've got a lot of, I guess, misunderstanding about the 28-day thing. Okay, guys. Oh, what about 28-day curing of the? Whoa, guys, it's 28-day strength, not 28 days of curing.
You're sealing.
Okay, the sealing at that point. The cleaning it, the doing that. We've got to make sure that we're understanding terms and understanding what each of these things mean.
Sure.
Right. The reason that we want to wait until 28 days is we want that concrete to actually hydrate and get to strength. We want, if we're going to be doing whatever post-processing to it, we want the chemistry to be available for these different colorants and densifiers, the sealers, any of the things that are reacting with. We want that water of convenience to actually have dried, and the constituents that it left behind is what a lot of these chemistries are going to be reacting with. So if we're using everything properly, it's not, make sure you're understanding terms. It's not 28 days of curing. It's 28 day strength. It's that looking for that 28 days, right, of maturity.
Sure. All right. And then so when we're sealing, 28-day sealing, decorative, I guess whatever, something with siloxane in it is going to be hugely beneficial. And then if we wanted to go with
before you put down one of your sexy, wet look, right?
Guys, be careful for anybody out there that does stamped or decorative concrete. If you're using integral color, you be really careful not to use a penetrating sealer with silane siloxane blend and not go back over that with a solvent-based acrylic, because as most of you know, a tan or brown color, when it's dry, it turns peachy, and you will lock that color in. So be very careful doing that. Make sure you're going to go back over that with a solvent-based acrylic or some kind of color-enhancing sealer after.
Will that solvent darken it back out after that?
It will.
Okay.
Yep.
Good.
That's good to know.
Yep. That's really good to know, actually, because I know because I saw the I think it was a video you posted, Ben, where you had just used the siloxane on a stamp job, I believe, and it was really good at beating water. But I noticed that color a little bit, and I was like, oh, it didn't darken out at all.
That was color hardener as well. Now you can get away with that on color hardener, and it's not gonna look like it's sealed. In my opinion, I like that look. I like how it looks before it's sealed. I just think it's more natural. I don't think stone and wood's supposed to be shiny, but that's just my opinion.
Sure.
Yeah. Thank you, Ben.
I agree with that too. So that's
Yep. Yeah.
All right. Well, Bobby, do you feel a little bit better about going back to work tomorrow?
I'm going to work either way, but I do. I really feel good about just participating in the whole, just having this dialogue with the industry professionals, man, and the peers, that pour concrete every day.
Yep.
We have to get this thing started somewhere because, like you said, it's here. Just the things that that I took away, just to add no more water. I need to add more water. Like you were saying, there were rules that we were taught against. Putting the poly down right away, or the evap retarder immediately. Doing that. The double sealing, the siloxane first, and then going back over it. I would have never done that. I would have just did either or.
Right.
And I would have done it probably in 2 days. The next day when I go back after I cut it. So I am going to try wooden bull float. I don't know if I think I have one at the shop, but I'm going to try that.
Yeah.
I am. I'm going to try all
Let
the
us
things
know.
that the guys are talking
Absolutely.
about here. And
They make fancy fiber ones too now, so you don't have to go old school wood. They make them fancy fiber ones.
The composite ones are the same, are basically the
Yes,
same
sir.
thing.
Yep.
Pretty much, yeah.
Yep.
Back in the day, we used to make them out of redwood.
Yeah. There's the
Yeah.
good ones.
So Bobby, when we're talking about adding water, guys, okay, we're not talking about going above. We're not talking about tempering or all the things that are ACI violations. We're talking about using your trim water that's there, right? We want you to that mix design to have that available water. Be looking at that. Make sure they're not dosing you way high on your mid range and your trying to cut you way back. Mike, you're raising your finger there.
I just had a conversation a couple of days ago. That trim water, it should be written on your ticket, you guys.
Absolutely, and that's your water.
People don't realize.
Listen, guys, I'm gonna caution you on this: that these guys are gonna come out here with this ready mix truck, and it's gonna be a 6 or 7 inch lump with chemicals. So
Correct.
that's why I said, hey, you're gonna bring it to me, and I'll add the chemical on site. That way, I got control of that concrete, and I can get my mixed water in there that I'm supposed to have. I might not need, but just a teeny bit of chemical to get to where I need to go. Instead of putting a gallon in, I might need an eighth of a gallon. You know what I'm saying?
Yeah, and what Steve just brought up is incredibly important, because after you add those admixtures, you're not supposed to add any water, right? There are certain of the admixtures that you're going to really throw that mix by adding water after the fact. And so that's why that trim, you need to be careful about what everything's there. It's not just about adding water, Bobby. It's what Steve said about, hey, bring me my mix and then let's add on site. Oh yeah,
they're gonna like that, but
they're gonna be mad at you.
You've got to have control of your mix.
Sure. Right on. Well, guys, I think this has been really beneficial, and I appreciate all you guys' time. I know there's going to be tons of questions. Feel free to answer the questions in the comments as we go. We'll continue to do this. We'll get it uploaded to YouTube as well, because Facebook will delete it in 30 days. So I will re-upload it to the channel, being that it's such an important topic, but we'll also upload it to YouTube if you guys want to go there. I'm sure people will comment questions you're welcome to answer on the YouTube as well. So it's CESYK Live, I think, is the YouTube channel.
Yeah.
So, yep. Cool. All right. Anything anybody you want to throw in here to wrap up?
I appreciate everybody. Sam, Don, everybody. I appreciate everybody.
Sure. Ben?
Yeah, I just wanted to say thank you to, Concrete Everything group. I've learned so much, and even through this conversation, humble enough, I've said this in the group, humble enough to admit that I don't know everything. I got a lot to learn, but I'm eager enough to keep learning. So this was hugely beneficial. And man, I think this is something that really needs a volume 2 and 3, but we can talk about that later.
Yep. It's definitely
every day. Every day is a learning.
Very specific elements of this could be broken down into.
And then I think that's what we'll get to. We'll get into some screen sharing and some good, some good document type stuff. So.
Yeah. Well, thank you all.
Cool. All right, guys.
We all have to be humble, Rocky, because otherwise concrete will humble us.
100%.
And that's what I was just going to say the same thing. Reach out. If you're really having a problem with a mix design, there's 300,000 members on this page. Ask the question. Hey, can somebody look at this mix design? It doesn't seem right. We're not having any luck with it. You'll get a response.
Yeah.
I mean, some people want to contribute to the solution. So
we're all in this together, so we're all trying to find the best thing possible. So,
Yep.
all right, guys. Well, I appreciate all your time. For all of you tuning in,
Thank
we
you, Ron.
appreciate you. Make sure you hop in the comment section, check out some of those questions and answers, and obviously, I think there's going to be a part 2. So we'll see you on the next one.
Good night, fellas.
Thank you, guys. Good night.
Bye.
Thank you, everyone.